Well, welcome to Imperial College and welcome to this UKAN workshop on soundscapes. First thing, a few practicalities. Does this go? Wait a second. Here. First, there is no planned fire drill. So if you hear the fire alarm, you need to go out. You can go out from here or from there. There are two staircases. And the assembly point is where is the Queen's Tower. You can go there. Actually, there is no requirement to go there if you don't want to. You can go to get a coffee or something else. But if you hear the fire alarm, please do this. Toilets are here. So if you just go out here and on the right, then you'll have toilets in front of you. And there is one toilet at every floor. So you can just go down if they are occupied. There are just two here. So it's not many. I think this is all in terms of practicalities. Now, I've heard that some of you have problems accessing Eduroam. I really don't know why, because some can. But in case you have problems, at the entrance, there is a list of individual guest accounts for logging in at Imperial, the Imperial Wi-Fi, not Imperial WPA. So if you have a problem, just get yours, just tick it off, just put a line on it so that someone else doesn't use it because they're individual logins. Brilliant. Cool. Boring stuff done. Travel support, sorry, the ones of you who have requested travel support, you should have been contacted by Will from Bristol. If you haven't, then please get in touch and we'll help. And dietary requirements, we have received all your requirements and the food should be labeled when it arrives around lunchtime. Brilliant. Cool. We thought to start, considering that we're not too many, we thought about giving short introductions, everyone. So I hope you don't mind, and we're going to do it a bit like it was at school when I was little. So just saying a name and someone just says 10 seconds about themselves. Is it okay? Yeah. Brilliant. Then in alphabetical order, we have Adam Thomas. Cool. Aidan Hogg?
Yes, I'm Aidan. I'm a research associate at Imperial, and I work on Untitled Chapter.
Aidan, now that you're talking, did we start recording? Yeah. Oh, cool. Really? Sorry. Aidan is in charge of all the technicalities. I just wanted to be sure. Alistair Owens.
I'm with the lecture, using classical usabilities for the figures.
Alistair Moore. Alex Southern.
Hi, Alex. I'm from
Brilliant. Andrew Hill.
Andrew Hill. I found a place that Spatialize, which is a small low-cost.
Alice Eldridge.
Hi, I'm Eldridge. I work in Classifiers. I'm here to talk about
Barry Jobling. He can't come. Becky, Heath.
I'm Sam. I'm Cheryl, and I'm basically working assessment.
Ben Williams.
Everyone, I'm a PhD student at UCL and I'm studying Ecology.
Benjamin Fennick. No. Bill Davies.
Hi, I'm Bill. I'm from Salford University. I'm probably a professor. I'm probably less known for stuff on Soundscape, but I think I've worked in all four of them.
Bob Ashington. Brona Martin. Cameron Scott. I lost track. Duncan Wilson.
Duncan Wilson from UCL. People in the group.
Ed Baker. Emma Paxton. Coming later. Enzo De Sena. Francesca Letta. Federica Poznansky. Gavin Kearney. Jameson Muzioki. Jenna Lawson. Jan Kang. Julia Smirnova. Oh. Thank you. Loudon Nushin. No. Lin Wang. Lisa Lavia. Lorenzo Piccinali, it's me. I am a reader here at Imperial in audio experience design. My research area is mainly immersive audio from the psychoacoustics and the digital signal processing point of view. And I'm coordinating the UKAN special interest group in spatial acoustics and immersive audio, as you'll hear later. Magnus Jansson. Maria Luisa de Carvalho. Mark Plumley.
Hi, I'm Mark Plumley. I'm a ESRC fellow in AI for Sound and Professional Signal Processing. I work on sound recognition and involved in events, defense community.
Martin McVeigh. Miguel Garcia Pedroche. Neil Lependre.
Hi everyone, I'm Neil, PhD student here at the Biosecurity Imperial, and I'm working with Bto Acoustic for the long-term view of concepts, acoustic and environmental resilience.
Neil Spencer Bruce.
I'm a lecturer on MMD. My interest is in sound design, lecture in sound design, background in Soundscape, particularly create Soundscape.
Oliver Metcalf.
I am a research associate at Manchester University,
Workisama Das. Peter Rogers. Philip Jackson.
Hi, I'm Philip. I'm also from Surrey, presenter as well. And my area is machine listening. I'm most interested in spatial aspects of that.
Santiago Martinez Balvanera.
So I'm a PhD student from UCL, and I'm interested in sound detection for
Sarab Sethi.
I work on research at Cambridge, and I work on wireless.
Stuart Newson. Susan Whitrick. Thibault Visson. Tim Obermann. And Zoran Svetovic. Thank you. We finished the list. If I missed someone, yes, probably apologies if you're not on the list, but please.
Hi, my name is Carlos Abrahams. I am a PhD student, senior lecturer at Ecology consultant.
Thank you.
Yeah, my name is Kieran. I'm a master's student at Sussex.
Brilliant. Yes. Brilliant. Anyone else we missed? Yeah, please.
I'm Will. I'm a PhD student.
Thank you. Apologies if you were not on the list. We're going to add you, of course. Well, thanks for doing this. I think it worked relatively well, and it's amazing to see how diverse this sort of group is, which was one of the real reason why we wanted to organize this. So sorry? 37. Wow. For the people online, thanks for attending online. The idea for this workshop was to run in person, so we're going to stream it, but the online participation is going to be limited to questions for the presentations, and you can type your questions in the chat. We're going to record this presentation, as you all know. If you have a problem with this, please come to me, and if you are presenting, you should sign here that you are okay for us to record the presentation, stream it, and it's probably going to go on the UKAN YouTube channel. So, well, the first goal for us was to explore UK research in Soundscape and encourage knowledge exchange in future directions, and try to put together people that would not normally attend the same type of conference. And I think we've sort of managed it. As I mean, I've heard, well, for example, Duncan, that you knew only 2 people here, which is great. And I know very little people here, which is also great. So the idea is really to put together different people working on a similar topic in a room, and then maybe come up with some discussions, some ideas, and some conversations. So the structure of the morning session is going to be more, let's say, taught, if you want to say. So it's going to be more presentation, and then obviously question and discussion, while in the afternoon we're going to run a word cafe activity, and we're going to tell you more about how that works, and a final panel at the end of the day. In the morning, we're going to have 3 sessions. We're not going to have a break, because, well, we started at 10:30, so we can probably run until the end without having a break. The first one is going to focus about Soundscape and capture of Soundscape, and I'm going to lead that and call different participants to contribute. Then we're going to have a session about how Soundscapes are analyzed, and finally a session about what we can do with the information that we have analyzed, so talking more about policy. Now, an important disclaimer here, we are missing a lot of things and research and professional work about Soundscape. You're not aiming for this morning to be comprehensive of all what we do here and all what is done in Soundscape. There is a lot of work, for example, on the artistic side. I see that many of you are more composers, for example, which is great. So just to be sure, this is not meant to be a comprehensive presentation, but just a way to look at different aspects of the same topic. So this is the plan of the day. You have received it. There is anyway a printed flyer at the entrance if you want it. And very, very quickly, this workshop has been organized by 5 SIGs, actually. The first one is Spatial Acoustic and Immersive Audio, which is the SIG that I'm coordinating together with Aidan, who is the early career, and Filippo Fazzi from Southampton. The idea is to bring together researchers in the area of spatial acoustics and immersive audio, looking at acquisition, rendering, human perception, and application. So all the space and different topics and applications of immersive audio. We have actually recently run an exercise trying to map the activities of our SIG, and I thought it would be interesting to show the different clusters that they came up. So the members of the SIG more or less work in areas such as spatial audio engineering, so binaural and HRTF. We work in numerical methods and simulation, again in spatial audio application, so music and design, and finally spatial hearing, so more the psychoacoustics. So this sort of maps the SIG. I'm going to call here, John, do you want to come to say something about? Oh, well, you can say something, you're here. Oh, sorry.
Yeah, this is another SIG, noise and soundscape. At the beginning, we were thinking maybe we should divide noise and soundscape as 2, but then we thought we should integrate rather than divide. So it's concerned about noise and beyond for soundscape, not only built environment, but also natural environment. Consider these noise sources and also cover not only research side, but also policy side, and as can be reflected for today's session. Next one. And as I said, the membership includes researcher, practitioners, policymakers, and from different sectors. And there are some current activities. In addition to this workshop, we are doing a national park, UKAN National Park soundscape mapping. It's ongoing. Hopefully, we will give you more information later and get support from everyone. This includes capturing and analyzing, and also public engagement. That's 3 people you can contact for the SIG. Sorry.
Thanks. Ollie, do you want to come up quickly?
Hi. Yes, so we're the Bioacoustics SIG. So I'm here today, Oliver Metcalf. There's also Helen Whitehead, Professor Mark Holderreid, and William Cresswell from Bristol. And yes, so it's a special interest group for all aspects of sound production, dispersion, reception in the natural world. So it's really quite a broad group. It includes things like neurobiology and engineering acoustics, but the organisers at least are more focused on the biology aspects of things, or our backgrounds are more biology, ecology side of things, so more wildlife monitoring. And it's forum for those working in bioacoustics to exchange ideas and collaborations. And at the moment, most of our focus is on organising an event on the 15th and 16th of June. There's some posters dotted around the back of the room on some guidelines for long-term ecoacoustic monitoring. So take a look at that if that's the sort of thing you'd be interested in.
Mark?
Yeah, thanks. So I'm just going to say a couple of words about the communication and room acoustics SIG. So this is sound to communicate from people to people, speech, music, hearing, and so on. We're working with standards bodies on things like face masks, video conference, hearing technology. There was an event last week. There's a link down at the bottom to the SIG there, but just think about, this is sound as used to get information from one place to another. Next slide. And so some of the ideas, there have been seminars about things like Quiet Project, interesting Here for Tomorrow workshop that was happening a few days ago, and the idea of the staying in the quietest room in London until I went crazy video, which is just about out. So Steve Dance will know more about that. There's more things coming up, including with the BBC Centenary later on this year, and meetings planned on architectural acoustics and metamaterials and lecture capture. So watch this space.
Thank you very much. And then the early career group, maybe I say something. I mean, I would send the slide. So the early career activities, the early career special interest group financed also this and contributed to this event. In fact, we have actually tried to put a lot of attention in trying to select attenders from early career researchers. And here is just a list of some of the activities they have supported in the last year, and some of the events that actually have been organized and will be organized in the next coming months. Actually, the last one is the one that will come in May 2022, manufacturing and transport. Now, I know that there are here also people that are not members of UKAN. If you want to be a member of the UK Acoustic Network, just join UKAN from the website. You can just go in, join, and select the special interest group you're interested in, and you will then be included in the mailing list and receive information about events like this or other events. I would very much encourage you to join. It's a very interesting space. And I have to say, having been more active in UKAN just in the last year, I think there are resources to do nice things. If you have good ideas, then they can be generally supported, and you can organize things such as this one, which actually we started thinking about it just last summer and just happened. So I encourage you to do so. And then I have received these from, again, from UKAN. Is something that I'd like to advertise. There is some funding in UKAN, and they have booked a sort of a course on public engagement. So if anyone is interested, please do look at this slide, well, look at the link, take a picture, or come to me later and I will send you individually the link on where to subscribe so that you can join potentially the training. The training is spread over 6 months, 3-4 days in total. And it will probably be a very good thing for early career researchers, but also for more seasoned researchers who wants to train a bit more in public engagement. So either take a picture of this, you can have a look at the recording, or come to me and I will send you an email, or email UKAN directly. Brilliant. So this is it from the presentation introduction. So I guess we can start with the first session straight away, unless there are questions or feedback or anything. I suggest we start then, and I'll open session 1 presentation. And it's still me, so I can stay here. Brilliant. Now for this session, we have about, actually, I don't know precisely in time, 45 or 50 minutes. And the presentations are very short, and I'll try to give a sort of a narrative across these presentations. The idea is to focus on capturing soundscapes. So various techniques, various devices that are available, and looking at other specific topics. Again, not trying to be comprehensive, but trying to give some sort of a nice overview of a few studies. I would be keen potentially for this to become a more interactive session. So I'd be happy if the speakers of this session are happy for people to ask questions during the presentation. So raise your hand and we can make this a little bit more interactive. Now, Becky is in charge of our Zoom channel. So if you have a question from online, just type it. Unfortunately, we'll need to prioritize questions in person, but we will try to ask some questions online as well. So if you have a question, just type it there. And if you have a question or feedback during the presentation, raise your hand and we'll try to accommodate that. So as you can see, we have a lot of presenters from many different institutions and many different fields talking about many different things. So the first part is going to focus on how we capture soundscapes in terms of hardware. So we're going to talk about devices. Sarab is going to talk about Bug. Andy is going to talk about Audiomath. And then Becky's going to talk about spatial acoustics, so having a spatial recorder, which at the moment is just a prototype, but she's going to say more about that. Then we'll talk about benchmarking. How can we assess how good these devices are? And Neil is going to talk about his project of using virtual reality and spatial acoustics to assess devices. And then we'll talk about specific challenges. We'll have Duncan that's going to talk about Shazam for bats. In this case, it's a slightly different type of approach. Rather than just having a recorder that records and stream or records and store, this is a recorder that is going to also process the sound and do something on the edge, which is going to be interesting to hear. And then where do we position recorder? We have Jenna Lozo, that is going to talk a bit more about area robotics. And finally, Ed Baker is going to talk about future challenges on soundscape capture and also a little bit beyond. And then we leave it to the next section that is going to talk about soundscape analysis. I hope this is all clear and fine. And how do we capture soundscapes? So we start with looking at devices. So Sarab, Andy, and Becky. The first two are going to be single microphone, and the last one is going to be a multi-microphone. Sarab, can I call you up here? I've asked the presenters to stick to 4 minutes.
4 minutes.
The microphone mutes automatically. It doesn't, but
There we are. Okay, I'm ready. Cool. Hi, I'm Sarab. Yeah, I'll talk about bugs. So this was based on, can't remember if I put it, no. So this is based on, a while ago in 2018, we released a paper on how you could use a Raspberry Pi for real-time acoustic monitoring of ecosystems. At that point, it was very much a Raspberry Pi connected to a Huawei dongle and like a microphone and a USB sound card, and it was stuck in a garden box. But since then, we sort of, it worked, but it didn't work for putting 50 devices out over a year at a time. The reliability issues became a problem at that point. So we created Bug, which is, this is a Bug device. It's like a custom injection molded enclosure. Inside it are a few custom PCBs that we made, which have the Raspberry Pi compute module. And we tend to power them in deployments. This is in Mexico. It's a bamboo sort of stilted solar panel with a battery. That's in Norway, where we've got a real-time monitoring network going. So they tend to be put out for, as I said, 6 months minimum, a year longer. Really, we're at the point of testing how far we can push it. It should be said, we're going to make all of this open source, which I'm quite happy about eventually, after much fighting with Imperial's commercialization team. There's one side which is a hardware, which is good, and we want to open source it and people to build it on. And the next side is we've created sort of a web dashboard for when all the audio comes in. It's based on Google Cloud Services. So you can configure the device here, you download a config file, you stick it on the device, and it should have said the device has a mono mic, omnidirectional MEMS microphone module. And you can sort of see how it's working out in the field. You got covered, we put the thing out there and we were there. So it's like, oh, it's worked all the last few days. That's kind of boring stuff. Slightly more exciting stuff is we've got real-time analyses running in a kind of modular way on our platform. So we also did some work on audio features that might be talked about later. There's the BirdNet project at Cornell, which is a general purpose bird detector from audio soundscapes. And we've done other stuff on anomaly detection. And we've implemented all of these analyses. So you see BirdNet like VGG-ish anomaly detection, but you can stick in other analyses. And as the audio comes in, it gets analyzed on Google Cloud Services in this sort of scalable way. It's cool. It's fun. You can export it. You can do management with it. You can do science with it. Yeah. I don't have too much else to say. I was too quick. But yeah. Questions? Yeah, please. Yeah.
I'm interested to know if you see much difference between microphones between devices in your system.
So they're MEMS microphones, so they should be pretty repeatable. We haven't done like super tight calibrations between we're just taking them off the factory and putting them in the same. We're trying to. One major challenge right now is, to get from injection molded enclosure, a bunch of bits, bunch of PCBs into the assembly. Right now, it's a bit manual, but we're training up a box build company to do this. So hopefully, any of you could want 50 and you could go to our box build company and they could build them. And hopefully at that point, the manufacturing process of how the microphone's placed within, we've right now got very good alignment and stuff, but getting people to do it professionally, create jigs to do it really repeatedly, that should make it better. Yeah.
If I may, the environment where a microphone is placed is the one that is most likely to create.
Absolutely. You see this, right? Like that's like facing under, it should have been facing the other way, really. But whether it's like an old growth forest with a 50-meter canopy or sort of scrubby stuff at safe,
What else do you maybe? I mean, the electric beginning you had electric microphones and those were quite effective, right?
Yeah. More questions? Yeah. Okay. Yeah.
So the analysis that you showed at the end, how much variability do you see between the difference?
So they're doing different things. We're not testing the same classifier doing bird detection, for example. There's kind of two aspects, right? This very much is implementation. We do our own research on how well the bird stuff's working. Actually, in Norway, we did an assessment of how well BirdNet worked. And for 21 species, it was 100% precise. For another 10, 15, it was more than 70% precise, and then for a few, it tanked. So, but that was for Norway for our project there, for where we're deploying it. I'd recommend, you know, you reassess for whichever condition you're in.
Some other question?
Yeah.
I forgot this because for the people online.
I was just wondering about I can see there that you're using solar panels to power it over long term. Is that a requirement, or batteries? How long do they last without the solar? Or?
So it goes from, it's quite power hungry compared to what Andy's going to talk about, the audio moth, for example. It's like, I think 1, maybe 2 watts, some between there. But it takes a DC 5 to 36 voltage input. So if you power that from the wall or from a solar panel or whatever, it doesn't matter. It's just, the point is, you know, if you want to do 6 months deployments, you have to do solar panels. You can't just stick out a battery the size of the house. And we've tried.
Cool. Thank you, Sarah. Then I'd call Andy to come up and talk about audio moth, which is another recorder. Actually, in this case, it's been going for much longer than us.
Thank you. Can you change the slides of this?
Oh no, you just need to press the space bar. Sorry.
Oh, okay, great. Yeah, nice. All right, cool. So I'm Andy Hill, co-founder of Open Acoustic Devices, which is a small UK company that designs and develops open source acoustic monitoring devices for conservation and wildlife research, with the aim to try and lower the barriers to entry to acoustics. In this short talk, I'm going to be introducing audio moth and also describing some of our developments that we're going to be releasing in the future. So this is audio moth. It's a low cost, you can pass it around and open up. So this is a low cost acoustic monitoring device. It's designed to be really flexible and minimal in its construction and also its features. So as you can see, it's only got a PCB, printed circuit board, and a battery holder. And in between those two components, everything you need to record acoustics in the field. So it's got a micro SD card, USB, micro USB, a switch, and analog MEMS microphone, which is it can record both audible and ultrasonic sounds simultaneously. And what makes this device really flexible is that it's really minimal in its construction. So it can be deployed in DIY cases, such as sandwich bags, or IPX7 waterproof case, which you can see there. Another benefit of being simple to construct is that it's really cheap to manufacture. So a device is available for less than 100 US dollars, so about £70. With a simple construction, you can expose really useful pins. So we expose a 3.5mm jack socket, so you can add hydrophones to it and PIP microphones, electric condenser microphones, and also GPIO pins, so you can add modules to the device, such as GPS. As well as being flexible in the hardware capacity, it's also got lots of software which is available on GitHub, which is all open source. And this can convert the device into a real-time bat detector, like this one. So you can plug it straight into your phone. And it can be used as a USB microphone. So you can use it to plug it into your Raspberry Pi and make it into an ultrasonic device, or you can put it into a computer to make it into an ultrasonic microphone. And I use it off my boat. I've got a small boat on the Isle of Wight, and I use my phone to detect porpoise clicks on the boat or marine life with the external microphone attached. So available on GitHub is firmware to mobile phone apps, which can be used. I'll go back one slide. Oh, can you go back slides?
Oh, yeah, I think you could just with the keys.
So yeah, also we have mobile phone apps which are available. So they run on Android and iOS. And these can be used for citizen science projects. So you can configure a device using an audible chime, which is detected by the microphone and converted to a timestamp. We also have desktop apps, and I'll use these desktop apps to describe some of the hardware capabilities. So this is the AudioMoth configuration app, which is used to configure the device for the first time. And after that, all the configurations are persistent on power down. So it can sample from 8 kilohertz to 384 kilohertz. So it can record bird song and also ultrasonic backcalls. It's got adjustable gain settings. And you can enable or turn off the cyclic recordings in between different recording schedules. So you can have 4 recording schedules a day. This is where the device turns off and wakes up. And then with these recording schedules, it gives you total amount of memory used a day and also how much power it uses a day, so you can work out how long the batteries will last. It also has filtering and onboard detection available. So you have amplitude threshold. So with this, you can, if an amplitude goes over a certain threshold, it records only that sound. And later you can use the same app to expand that recording to fill the silence gaps. So you still get all the time data. It also has frequency filtering. So this is coming out in the next few weeks, where you can choose frequencies and filter based on that. And that uses the Gertzel algorithm, which is a really fast way of doing fast Fourier transforms. To support the filtering, we also have a web app called the AudioMoth Filter Playground. And with this, you can go onto a website, upload an AudioMoth recording, and play around with amplitude threshold settings and frequency settings, just to see what your recording will do on the device. So filtering on the device. And that's on openacousticdevices.info/filter playground. We've also got other boards. So although AudioMoth is really flexible, it can be used as a standalone logger or a AudioMoth USB microphone. We also have other products, which is Micromoth, which is this little device, which you can pass around, which is exactly the same as AudioMoth, but everything's made really small. And with that, you can attach really small batteries, so it can be deployed on animals. We have AudioMoth Dev, which is exactly the same as AudioMoth again, but with exposed JST headers. So you can add modules like our GPS module to get really accurate timestamps, so you can localize multiple devices and do triangulation. We have AudioMoth USB mic, which is exactly the same as AudioMoth without the SD card. So this, you can do the same thing as this, but without the microphone, without the SD card. And then also Hydromoth, which we're developing and releasing in a few months' time, which is an underwater version that can be used down to 100 meters underground, no, under the water, and that can be used to record marine life. And that can be turned off and on with a magnetic switch. Thanks for listening. If you want to learn more about us, you can visit our website at openacousticdevices.info.
Do you have any question?
Oh, yeah.
Board with
So
additional
it's,
features on. Sorry,
no, it's so it's the same board, same audio front end, but it's got a magnetic switch, so you can turn it off and on without opening the case.
Any questions from Zoom? Brilliant.
That will be in a few weeks time. Yeah. Yeah, so we're doing some tests at the moment at National Physics Laboratory. So we're doing some omnidirectionality tests and sensitivity tests. So that's ongoing. So we're going to try and get some accurate readings for that.
Very much. Great.
Thank you.
Thank you. So the next. Oh, sorry, we have this. Cool. Sorry, here we go. So we've been looking at two devices up to now that have a single microphone, and now Becky's going to tell you more about the device that she's been prototyping that has got multiple microphones.
Yep. Hi, so basically I'm going to be talking about how we can use multiple microphones to spatialize sounds. What that means, what we've had to do with the hardware, and where we're at in terms of how that project's going. Ooh, this one. So when you're out in the world, just so we're all on the same page, when you hear a bird or something, you can, without really thinking, spatialize where that is based on the signal that hits each of your ears. So in short, the closer the thing is to you, it will hit that the ear that's it will hit the ear that's closer first, and it will be slightly louder at the ear that's closer. This is a very simplified version of how that works, but just basically we can sub out our ears for microphones and perform sort of similar analyses. In practice, when we put multiple microphones out into the field, there are two main routes we can go down with this. There's hyperbolic positioning, which is where you have an array of microphones and the thing you're looking for walks through it. And there's direction of arrival type of spatializing, where you've got all the microphones in one place and then you're guessing a position relative to the hub of microphones. In terms of ecology, the reason we can use this is it gives us a much better predictor of how many organisms there are. For example, if you've got a signal and you've got 15 gull calls, you can, using spatialization, you can determine whether that's one gull calling 15 times or 5 or however many you have actually in space. We can get things like interaction, habitat use, and some sort of like boundary or territory markers as well. So the device I've been working on is based on the early developed device that Sarah was working on. So it's a Raspberry Pi based computing unit with a solar charged sustainable energy source, which is connected via the internet via a mobile dongle. What we're essentially doing is swapping out the microphone for an array. So a fixed array, which we chose as it's really cheap. So we can get quite sophisticated tetrahedral microphones, but they tend to come in at about £300 a go. This one costs in the region of 30 to 40. So it's a much cheaper way of doing things. We've had really successful lab tests, getting accuracies up to 5 degrees in terms of like directionality, and now we're in the process of field testing it. At present, we've got 3,500 hours, and I'm in the process of building the analysis pipeline for use in the field. So that was a very quick tour of what I've been up to. Is there any questions? Yeah, so it's mostly direction for the minute, but using things like you can work out by how loud the signal is. Sometimes you can do some inference of how far away it is, similar to how you would have omnidirectional.
How do you consider environmental effect, like a building, sun, or big trees?
Yeah, so the directionality of the device we've got, because it's only 2-dimensional, we're looking at a sort of a sweep of directionality kind of going that way. So it's not completely 360, more sort of 180. So we generally will face the recorder away from that. But yeah, no, that is something that would have to be considered if there was a big obstruction. But for the part we're at now, we're focusing on, yeah. Anomalies. So are you talking about event detection kind of stuff? Yeah, so I've been using at the minute, so I'm trialing a bunch of different softwares. For the lab tests, I used a platform called Heartbird, which is basically a multi-channel event detection, source separation, and it like does a lot of the localization within an app. But there are other things like ODAS, and I think PAMGuard, I think, has some platform for doing event detection based stuff.
Any question from Zoom?
Nope.
Well, then if there is nothing else, then we'll move on. Thank you.
You're welcome. Oh, you can, yeah. Grab that.
So after we have seen a sort of a very quick overview on some devices, some prototypes, and some devices you can actually buy directly for carrying out recordings. Some of them are autonomous, some are require maybe to be attached to a battery or power or etc. The idea of this next presentation is to look at how we can assess these devices. Now, sorry. So, for example, in the works we have done here, like with Becky has put these devices on a tree. Same thing with Sarah. We have several in Borneo and in other places. And then we get thousands of hours of recording to assess how the devices worked. We are now trying to move into another direction that is parallel to this, which is to start looking at assessing and benchmarking the device in a lab without just relying on simple single loudspeaker, but relying on acoustic virtual reality. So trying to simulate spatial sound fields and trying to see how we can assess how the device will perform in the forest, but in a safer environment. So I leave it to Neil to talk to you a bit more about this.
So hello everyone, I'm Neil. I'm a first year PhD student, as I mentioned earlier, here at the Dyson School in the Audio Experience Design Group, and the project I'm working on builds on the Safe Acoustics project, which both Becky and Sarah, who you've heard from so far, have worked on. And my longer term goal is going to be to look at whether we can use ecoacoustics to assess ecosystem resilience and how that's changing. But as a kind of first step within my PhD, I'm actually looking at building a test platform specifically looking at evaluating these spatial ecoacoustic field recorders. So today I'm going to tell you a little bit about why we're doing that and then how we're planning to do it as well. So firstly, why? Well, from a personal point of view, I came from a design engineering background as well. So this seemed like a kind of useful first step within my PhD to transition from working just on engineering to also looking at an ecological research context. But probably more importantly, as you've heard a little bit from Becky, these spatial recorders can be really insightful devices. You can measure different metrics than you could with a single channel device, for instance, like abundance data, but they're relatively novel. And we don't know too much about what's the best way to deploy them. So the question is, how can we accurately test and optimize these devices when no two real world soundscapes are the same? And ideally, of course, we need a kind of benchmark soundscape or benchmark set of soundscapes to measure against. And then finally, the kind of third reason we're looking into this project at the moment is that there's various ways we can extend it further down the line. One might be to test obviously other recording devices as well, including maybe single directional ones in certain tests. But the other that's quite interesting is potentially changing our setup to not measure different devices, but to measure different types of algorithms that do ecoacoustic analyses. So again, by reproducing soundscapes that we've captured, we might be able to evaluate these different algorithms. And hopefully that'll become a bit clearer as I explain how we're planning to test these spatial devices. So the first thing that we need, and what we're building actually at the moment, is a spatial soundscape playback rig. And so the idea here is we're going to have a sphere of loudspeakers effectively, so probably around 31 Genelec 8010 loudspeakers that are going to be on this spherical dome. And then those are going to be powered by two Motu rack interfaces and a max patch that's going to be rendering the ambisonic audio and sending it through to these 31 separate channels to create hopefully a relatively accurate and immersive playback system to reproduce soundscapes as though they were as they are in the real world. Then the second step is to go out and actually record some soundscapes. So we're planning some field work at the moment, just locally. We might be looking at going further afield with this in the summer and perhaps beyond. But at the moment, we're going to be doing some recording at the Silwood Park campus at Imperial, which is just out of London, sort of towards Reading area. We're capturing soundscapes there with a high quality microphone, a Zilia microphone with multiple microphone capsules within it, and also the field recorder. And the goal is then going to be to reproduce the high quality soundscapes that we've captured with the Zilia microphone in the lab with the multi-microphone system and re-record those soundscapes with the devices, the spatial field recorders that we're hoping to test. And the idea is that we might be able to then compare various analyses between both the field and the lab, but also different configurations of the recorders in the lab. So what difference does the orientation, for instance, of Becky's device make, whether it's oriented horizontally or vertically? How does the waterproofing and housing of the device change the type of results that we get from some of the analyses? And some of the analyses that we're looking at are some of the same ones that Becky's been working on. So this is just a general screenshot taken from the Harkbird platform, which is giving you kind of event detection and the azimuth, or the direction that some of these different events are coming from. So that's a bit of a whistle-stop tour through what we're hoping to do in this initial project. As I've mentioned, I'm still at the very start of this journey. So thanks a lot for listening, and do get in touch if you have thoughts or questions. And of course, I'm happy to take some right now as well.
Do you have any questions related to this? Anyone from online? Yes. Yeah, the mic.
Yeah.
Can I throw it?
Thank you. I'm just question you. You said you're going to compare those recordings. What kind of sort of comparison are you going to look at? What differences? How are you going to evaluate quality?
Yeah, that's a great question. The first step is going to be to just compare directly the results that we get from some of the standard analyses that we want to use in the field. So at the moment, we're kind of using a combination in particular with Becky's work on BirdNet, which you've heard a little bit about for identifying various avian species, and then Harkbird. So hopefully, as a first step, we'll have a kind of pipeline using BirdNet to identify avian species, and then Harkbird to identify where they're coming from in space, and see whether those results actually differ between the field and different lab setups.
Thanks. That was really interesting. I've got two quick questions. The first, I'm guessing, is optimistic, but do you have any plans to try it with underwater setups? If you did, I'd be really interested. And also, do you plan to test perhaps placing devices on something? So, if it's put on a tree and there's this object in the way or something like that. So something that could perhaps fit under the dome to see if there's a shielding impact, anything like that.
So I think those are both great considerations. At the moment, they're not factored into our immediate plans, but hopefully the idea is to have a setup like the one I showed you installed more long-term. From a practical point of view, at the moment, we're figuring out getting a space that we can maybe have that setup be more permanent. And at that point, either through our setups or maybe other ones that are developed, maybe at other labs across the country, we could maybe start to explore some of those things. So underwater acoustics isn't something that I am looking at too much, but I think it could be a really interesting aspect. And then certainly doing things like introducing maybe things that you might see in the field, like obstacles and whatnot, and trying to replicate those in the lab, I think would be a really interesting. Yeah, I think that'll be a great. We're not going to flood the lab, unfortunately not. I mean, it could be interesting. Maybe we can take the rig to the swimming pool or something. Yeah, but I think those are great suggestions. And it would be interesting to get more people working in this area so that we can actually test these different recorders and in more different scenarios.
Thanks. I wanted to ask, I mean, if your goal is ambisonics reproduction, I mean, for testing, how come you didn't decide to design, to go after a ambisonics microphone, but rather use this hexagonal
I think that might be
shape?
Misexplained from my part. So we are using an ambisonic microphone to capture the high quality soundscape.
Sure.
And then we want to reproduce that in the lab.
But why isn't your spatial microphone, why is it not following the ambisonics design principles?
So in terms of this project, the ambisonic microphone and that side of things is purely based on trying to, as accurately as possible, replicate a real world soundscape in the lab so that we can reproduce it repeatedly. So from that point of view, we're using ambisonics purely for that, for as best reproduction as possible. Then in terms of the 6 microphone device, Becky might want to say a bit more about that, but that was kind of chosen more for its purpose as a field recorder. So I guess it's kind of, one is we're using just for this high quality reproduction, and then the other is the device that we actually want to see in the field. Becky, do you want to say any words about?
So that's the reason that we chose to use the little 6 mic instead of ambisonic. But mostly to do the cost. Because the point of making these devices was to make them like cheap and easy to use, really the ambisonic mic They require a lot of handling, and so they are like just for the microphone alone. So the solution we've chosen is a very useful solution.
Also that I mean, a 6 microphone array can still be encoded on the sonic domain. In our case, we're really looking at the direction of arrival estimation, looking at the information of delays between the microphones, and sometimes the sonic microphones are not good for that. So at the moment, we went really for the option that allows us to buy a board that had all the microphones cost £30 and without developing that. That is the direction, and I'm not aware of any space of the sonic microphone that has that cost. Anyway, all the processing we're doing is not based on ultrasonic at the moment. Any other question? Oh, sorry. You have Thank you. Thanks, Neil. Thank you very much. So, well, if you look then at the challenges, in the soundscape capturing, and most of all remote soundscape capturing, the presentation we've seen so far outlined that there is a first challenge of powering. For example, AudioBot has got some batteries that are usable and can be powered externally. You've seen some of the pictures from Sarab and from Becky that these devices, despite being relatively small, they do require the solar panel to be powered for extensive amount of times. Therefore, powering is definitely a challenge. And the other challenge is connectivity. So at the moment, for example, the AudioMOS does not have an inbuilt streamer, but you can potentially attach one. But the Bug, for example, has one. But we need to rely on 3G network being available in the area. A byte might be also slow, but we need to rely on some level of connectivity to stream raw audio data. Because up to now, we have looked at devices that collect audio and stream audio. And the next presentation is going to focus on a more of a different type of approach, where the device itself is also performing some analysis and streaming some information or parameters or data that is not just audio. And here I'd like to invite Duncan Wilson to tell us more about this project and this slightly different approach from what we've seen so far. Oh, sorry, this is better.
Thank you. So, yeah, so this is, so within CASA, the work that I do is I'm really interested in how we can do this idea of continuous monitoring of our built and natural environments. And so back in 2017, we had this notion of a living lab in the park. We had lots of different sensor systems that were out and deployed, but we had lots of things like temperature sensors, humidity sensors, sort of small, low power devices that were quite easier to use. But these back boxes were some experimental devices that we used to try and explore this idea of doing the analysis of complex information at the edge. So we had 15 of these devices. They've been running since May 2017, and they're still very much a platform that we're using today. So what's inside them? There is this Intel Edison. I don't know if anybody saw this. It's now a dead product, but for a few years, it was the platform that Intel were using to try and power wearable type devices. So it's a very low power device, about the power of a kind of a 433 megahertz. So a Pentium 433 sort of device from the 90s. But then the goal was, and then we've got this Dodtronic Ultramic attached to it, so 192 kilohertz. And the idea for this board was for this device was to try and create a device that was going to connect over LoRa. So we had a LoRa gateway in the park at that point in time. But we found it really difficult to get the actual device running at low power enough for us to be able to either use a small enough solar panel or a small enough battery pack within the park environment. So it got to a point about a year into the project that we realized actually we just couldn't do that. So what that then meant was that we're going to have to power the device. So you can see there's a nice big black power cable coming out, and we've got a power supply in there. So we then dropped the LoRa because Wi-Fi is easier and it's built into the device. But we still had this goal of being able to try and pretend that we were going to be sending small packets of data off the device. So they're all mains powered, they're on lampposts around the park. The devices get exposed through MQTT, basically data coming out of the device. Then we've got a telegraph influx Grafana stack that's in the cloud for data visualization and the like. But all of the information is also stored. Sorry, information is also stored or can be stored on the device itself. Roughly when 12 boxes are running, we reckon there's about 180 gigabytes of data per day being generated, but only about 2 megabytes of data is actually being sent off the devices up to the cloud. So the process that we go through is that, so we've got the audio input, converting into a spectrogram, and then we run a detection CNN to basically identify back calls in the signal. And then we've also got a classifier as well that's running. And then those two calls are then they're stored in a MongoDB locally, so that if there's any kind of communications failure in the park, because guess what, the park Wi-Fi does drop down occasionally, we can store up to a week's worth of data locally on the device. When connectivity is restored, it then starts to backfill and keep sending those recordings off. In terms of the actual CNN that's being used, there's a paper called Bat Detective that describes the Bat Detect algorithm that we're using, that was developed within UCL Computer Science. This page here is just an example of some of the applications that we then build on top of this. So if you think that there's at this end of the pipeline, we're storing data locally in the MongoDB, but then we're sending it all off the device. So that MQTT interface then allows us to build a whole bunch of other things on top of that. So we've got visualizations over on the right. So this is a little app that you could see, that you could watch to see back calls as they're coming through live. And this is all sort of built on the scaffold of the MQTT service. We've actually had 4 or 5 different data backends since 2017 that we've been pushing this data into, because lots of them were switched off through the project. So that's been kind of one of the biggest headaches for us, is relying upon third-party services. And we're now hosting our own backend data store. And lastly, here is an image of a device that's in the park, just showing kind of where they are on the lamppost. This is pointing out, we use a random stratified sampling approach to actually decide where the microphone should be going in the park to be monitoring different kinds of landscape. I showed this just to say after 5, so this was a photo taken earlier this year, so that's 5 years on, and it still looks pretty good inside the box. And if you bear in mind that several of the boxes, when I've gone to open these, water has come out of the boxes as I've been emptying it. So my big tip for today is always raise the electronics above a good few inches above the bottom of the box, because even if it's IP rated, I don't know how water still gets in. Thank you.
Very much. Do we have any questions online or here? I guess we'll anyway have a chance to discuss more in the afternoon. Thank you very much. Very interesting. Thanks. Great. Brilliant. So let's move on. Whoops. Oh, sorry. So, well, Duncan touched a little bit about this, and Becky mentioned it as well. Where do we place our devices? They're using different methods in order to sample accurately, spatially sample different areas or different zones. And here we have Jenna Lawson from Imperial, another department from ours, who's going to tell us a bit more about her project, where, well, we're looking at a bit of a more flexible way of distributing devices and sensors.
You can get
I have one already, it's okay.
Okay, hi everyone. So I'm Jenna. I'm from the aeronautics department in Imperial and work in the aerial robotics lab. I should say, disclaimer, I'm not an engineer. I'm not an aerial robotics engineer. I'm a biologist. I'm just doing the environmental side for the environmental sensing side for the department. So today I'm going to talk to you about a new project that we've just recently started working on, and it's using robotics to try and actually place acoustic sensors in areas that are quite complex for us to access and hard to reach. So one of the problems that I'm sure we've all experienced is how we can actually get our devices into areas that are either dangerous for us to access or just downright impossible. So one of the areas that we're looking at into in the future is Arctic environments. Maybe some underwater environments are quite hard to access. Upper canopy has been the big one for me in my PhD research, how to get audios into the top of the canopy. And then more sensitive environments that maybe we can disturb just by trying to access them, such as marshlands and reed beds, places like that. And I'm sure there's many other environments that we can all think of that are hard to access. So our solution was to try and use robotics to actually access these environments. And to do this, we've been working on 2 proof of concept projects. So the first one is a forest-based project looking at how we can get audio devices into the top of the canopy. And then the second one was an aquatic project looking at how we can simultaneously record underwater environments and above water environments at the same time. And to illustrate this, I thought it probably easiest just to show you 2 videos. So this first drone is nicknamed Shooty, very good name by the engineer. And what this device does, I'll just play it to you while I'm talking. It flies up into the top of the canopy, and you'll see in a minute it's about to shoot the environmental sensor into the top of the tree. So I'll go back and play that again so you can see it's flying up. And it's got a little arrow that's going to be released and it shoots into the tree. And then what it does is when it flies down, there's a spool on it and there's a little wire that's actually attached to this sensor here. And then it pulls it down. So when you want to go and access it again, you can just tug on it. So that's the first one. And that's helped us to get microphones. Right now, we're working on sort of 15 to 20 meters up into the canopy. We're hoping to go and test in some tropical environments now we've got over this hurdle. And this one, okay. And then the second proof of concept project was the aquatic one. So I'll just go back and say on the, so we use all open acoustics devices. We use audio moths. So the first one we were using U-moths to place the devices in the upper canopy. And then we were actually simultaneously recording using the standard audio moth on the bottom of the canopy, just so we could see if we were actually getting a difference in the upper canopy and lower canopy. And then for the water-based project, we've been using the audio moth dev with a hydrophone attached and then a U-moth on the surface attached to the surface of the robot to record the birds. So this is Sailmav. This is an aerial sailing hybrid robot. And what this does, it can fly onto a water body and then the wings turn into sails and then it can autonomously sail around the lake into different environments. So we were testing this in Croatia most recently and we were sort of on a big open lake and then also trying to get in and out of different reed beds. And like I said, we have on here a hydrophone that's sort of attached to the robot, but it's dangling into the water, and then a U-moth on the top recording all the water birds. And I'm not going to go too much into the results here because we don't have time, but this just shows you, so these are long distance false color spectrograms that we created, and you can see dawn chorus and dusk chorus. And then this one is from the upper canopy, and then this one is from the shrub layer. So you can see, I mean, I did my whole PhD research placing audio recorders in the sort of shrub layer. And I always wondered what was happening 40 meters up in the upper canopy. And we can actually see that there is a difference in the soundscapes that we're getting. So hopefully in the future, we can place more audio devices in the upper canopy. And this is just the start. So the lab that I'm working for is expanding all sorts of environmental sensing with robotics and starting with acoustics. So.
Do we have questions briefly because we're running a little bit late? A question yet?
So it is legal. You do need a lot of permissions. Yeah, you need a lot of you need special licenses and permits. So for this work, I guess the limitation is that you do always need somebody who has a pilot's license for the robots. Sorry? So both of these robots are custom built by the lab, yeah.
Thank you very much. We move on. We'll have a bit later again. Thank you, Anna. Brilliant. So we've had a look at several devices. As I mentioned, this is not meant to be comprehensive. But to give you an example, we've recently started talking about, for example, biodegradable recorders that we can put and they would eventually die out and be, well, we don't need to go to pick them up. And there is a lot of technology that is going on that we haven't looked at. Maybe we'll have a chance to talk about this later in the afternoon, or anyway, this is a good way to get in touch and maybe follow up later on. So I leave it now to Ed Baker from the University of York Natural History Museum to tell us something more about the future challenges in soundscape capturing, and maybe also touching a bit on analysis, which is then the next session. So this is to you.
Thank you. So first of all, these two institutions work on two very different timescales, which is kind of where lots of this comes from. So we're living in the kind of project cycle in one, and at museum, we tend to think in terms of decades, quite often centuries, like we preserve stuff. So I do some stuff. I've been like describing some new species of cricket from recordings which are nearly 50 years old. So we have that kind of, we tend to think on those two different timescales. So in terms of like a museum interested in soundscape analysis, we're coming from a kind of a longer term view than like a single project. And when we kind of think of this, we kind of have three kind of things we have to balance. So like scope, scale, and speed, which is how we've been kind of thinking about what we do in this area. And so if we're going to make a network, we're thinking of like, so the museum is putting in, as part of the grounds redevelopment, a sensor network. So we're doing it in terms of, we're putting in power over Ethernet, we're putting in probably 50 sensors just in the front of the museum. So it's quite dense, it's power, and it's there for a long time. So we're hoping it's going to be there, like pretty much indefinitely. And it's more of a platform than a project. And so there's scope, which is like, you know, all these things we do in Bgo Acoustics, or like things we do here and harder things to do here. But over this scope and duration of this network, all of this is going to change. We're going to get more and more down here. We're going to have new things. So we have to kind of plan for that variance. And we're also doing a lot of stuff with context. So like abiotic sensors, so like temperature, light levels, how does like the amount of light reaching the floor due to like the seasons affect the environment. And so it's going for a very data-rich thing. Collect as much data as you can. We've got decades and probably tens of future people to look at this stuff, which is a very museum attitude. Just collect all the data. Later on, you can find something. So let's go in terms of scale. And like, you know, there's various ways you can scale things up. There's a lot of like more stuff. There's like more sensors closer together, cover a bigger area. But that's only one way to think about scale. One is moving from research projects to an infrastructure. So, you know, there's loads of great projects going on, like you all got involved in these wonderful projects. Someone in the future, like how do they take data from one project and compare it to data from another project? Or over this, maybe like the same place, or like over decades apart. Like these are questions which we need to think about. And this comes with this big problem, which is heterogeneity, which is like, you know, these are different devices comparing different things. And like even on a long-term project, like this heterogeneity is built in. So like, you know, devices fail in the field, we all know this. And if you're doing it over decades, you get to the point where like that's not available anymore. These things are going to change. So you kind of have to, documenting this heterogeneity is something to think about. These are just like broad things we've been thinking about. I'm not getting into like huge details about this, but these are things which is probably worth starting to think about to create like a long-term community idea of what ecoacoustics can do. And then speed, like, there are real-time projects. It's not always necessary. Like, people do collect data, analyze it later, but it starts to give us some new ideas of things to think about. So there's this classic one, which is like, poaching, like gunshot detection, things. Biosecurity is possibly like one of the untapped things here, which is invasive species. And I'm an insect person, right? So I kind of think about timber quite a lot. And we have projects where we can identify species of timber feeding beetles. But we can identify the species just from the clicks they make chewing through wood. And if you think about emerald ash borer in the US, these are like things which can devastate huge plantations. So there is something to be said, I think, in that, going into that area there. And I was going to leave it there because it's just broad oversight. But if anyone has questions or.
Thank you very much. Do we have any questions regarding this last bit or anything from the presentation? This is the end of this first session. Any questions? If we have any discussion, any feedback? Sarah?
Yeah. So there's kind of like two things which you have to do there. One is characterization, like which you've been doing or starting to do is characterize what these things can do. And the other one is just like, we need to document this when you're doing stuff. When you create data sets, you need to document those sensors. And we need like better, like long-term storage things and data sharing things. Me and you have discussed this quite a lot, right? So, and that for all the sensors, like light level sensors, everything, like you need as much information about what that device is. And you need to link that with the recordings and characterizations where available. If the characterization is not available, like you can probably get a broad sense of how two things compare if you use them in the same place. But like, the more information you have about what you're using, the easier this becomes in the future, I think.
Sorry, there was another question.
Do I need to press it? Is it on?
Sorry?
Yeah, I'm just a bit maybe not related to this presentation in particular, but the session itself. I've just got an impression that all the session is about capturing, it's about bioacoustics, ecology. I'm not really sure how it's related to soundscape, because soundscape has proper definition. It's like perceived by human. And also from practical aspects, like environment agency, we trying to assess effect of noise on species. And there is no research that says you what is the effect of noise, what it's going to be. Perhaps instead of maybe looking at practicalities or just details how we capture it, we need to also understand what is frequency of hearing of birds, different bird species, different, I don't know, animals, small animals, and just try to maybe raise a project. I'm not criticizing anything, but just as those two sessions, like at Soundscape and Bioacoustics, not really linked yet. Thank you. Sorry, maybe we'll discuss it later, but just came to my mind. Thank you.
I think it's interesting when you mentioned that soundscape is by definition as it's perceived by human. It would be interesting maybe to chat more about that. Yeah.
We have that as an aim.
Yeah. No, absolutely. That sounds very interesting potentially for the afternoon discussion as well, because yeah, cool, perfect. But anyway, there's going to be more sessions, and actually the next one I'll leave it to Ollie. Give it move forward towards what you were saying, and the final one is going to be more focusing on that. So I'll leave it to you, Ollie. Do you want to start any?
Yeah. So that was a really good first session. I really enjoyed that. I kind of want to talk more about all those things. But we're moving on now to more analysis of soundscapes. And we're starting off with Professor Mark Plumley from the University of Surrey.
Just F5. Okay, so let's just get rid of this for a second. Okay, so hi everyone, I'm Mark Plumley from University of Surrey. I said before I'm EPSRC Fellow in AI for Sound, and now I'm able to focus on this a bit more now we're getting out of COVID. So what I'm going to be talking about is just a bit of an introduction to some of the techniques on automatic recognition of sound. I'm not going to go into a lot of the detail here, but we talked about soundscapes being as people perceive it, but here this is about how machines perceive sounds and the elements of sound. So often when we talk about sound recognition, we're thinking of sort of three main tasks. Acoustic scene classification, where are you? Are you in a bus? Are you in a park, a restaurant? Audio tagging system, what are the sounds that you can hear within a clip of audio? And then sound event detection, where you're also interested in the start and stop times of those. When does that event start and finish? Some of these are not quite so clear. Car passing by might sort of fade in a bit. So sometimes these have a little bit of fuzzy edges on these. But I think this is something where this work on recognition really there wasn't a venue for this before about 10 years ago. So before about 2011, if you tried to find a conference or workshop to go and find out about recognition of real world sounds, there wasn't one. Music, yes, speech for ages, but not really environmental sounds. And so together with Mathieu Lagrange and others, people like Dan Stowell and Emmanuel Benetos, we put together a plan to collect sounds and create a data challenge at the time, which formed the initial detection and classification of acoustic scenes and events challenge DCASE 2013. So actually it's been running about 10 years now, including all of this. Now there's actually this should be updated. Now the next one, we're just waiting for the event in June, in November this year. So Barcelona was in the end an online one here. So this is really about creating a research community of people working in the same space. So as an example of the type of task that might be related to a soundscape, this is an early one for smart home applications. These were recordings from a domestic home, 7 hours. This is not huge amounts now, but there are issues of privacy and so on around the recording things in a domestic home. In the end, this was John Barker from Sheffield who made the recordings originally intended as background noise for a speech recognition task. And so he'd already done the filtering through to make sure these were reasonable things to release. What we did was added some simple labels on the top of here. Is it child speech, female speech, and so on? Actually, there was quite a bit of disagreement from the labelers here. So it was a bit of a tough job. We learned quite a lot from here. But now the data challenges have really expanded. The well-known one now is audio set, that many of you may have heard of. But for anyone who hasn't, this is based on Google YouTube videos. And essentially a sounds classified from YouTube videos. There are usage issues around the sounds for that. So they made a feature extraction available because the audio itself remains owned by the uploaders and they can withdraw permission from that at any time. So, but this was a large number of around 2 million 10-second segments, and some of the current trained neural network machines that are using this are trained on audio set. If you're interested in open sounds, then the free sound data set is another more recent one that's available from the UPF Barcelona people here. So an example approach from this is now a sort of classic approach, convolutional recurrent neural networks. Plug in your favorite deep learning model. People are talking about transformer models now. So it now becomes a point where really it's the data that's the focus of where the interest is. So what sort of data have you got that you can rely on? And for these generic sounds, do they really represent the things that have been captured or are interest to you? And so if you want to be able to drive these models, we need more in the way of of the data that fits the type of task that you're using, rather than just relying on YouTube videos and expecting that those have got representative samples of the things that you want to recognize. So there's a huge range of potential application areas here for the sound recognition. We've heard some of the environmental noise here. One of the things I'm interested in are the sort of human activity and also well-being in the home. So that's something that we're looking at. But also potentially for multimedia work. So we're working with BBC on searching through sound archives and so on from there. But if we think about soundscapes, then one of the things that was mentioned earlier is the impact that soundscapes have on people. And some work that we've been doing on participative engagement with people in the workplace and at home is about the effect that different sound items have on people. So could we use the type of automatic recognition technology that we've got to recognize the sounds that are pleasant for people, unpleasant, annoying, and help to automatically identify the type of soundscape that you've got. And if you're operating a building, it might tell the building organizers, the building operators, that this is not a nice soundscape that you've created for people to be in, and could you adjust it somehow? Now, some of the interesting things coming up in here anyway also is that these are very personal to people, and people might have different views about what sounds are pleasant or annoying to them. So I think there's more work needed in this about how to link this to the sound event recognition to where we might put that onto an affect map. So this is really the approach that we're taking in the AI for Sound project, is trying to start from the people perspective and use that to drive the research questions. So many of the AI projects that we've worked on in the past, you start from the data or the machine learning algorithms, and then you think, okay, we've created this thing, can somebody use it for something? Instead, we're trying to turn this around the other way and almost take what you might call a user experience design approach or a product design approach for this. So on this, we have specifically a research fellow in design research who's doing that front stage to tell us, oh, okay, well, we know we can build these devices, but this is the particular thing that we need to solve. For example, privacy is something we know that we're going to need to solve because the types of environments that we're living in. But if we could reduce some of the impacts of this, you know, to actually tell us much better, not just how loud something is, but how annoying something is, that would be a great advance for us to be able to work on here. So I think that's most of really what I wanted to talk about here, so that this sort of deep learning stuff can be used to recognize sounds. Now it's for us in this community, I think, to be able to want to work out what data that we need and how this might impact on people, and how we can use these tools for the benefit of improving people's lives, basically. So thanks very much.
Great, thank you. Does anyone have any questions? Anything online? No. Okay, so in which case we'll move swiftly on to Alice Eldridge from the University of Sussex.
It works. In the PowerPoint. That's the PowerPoint one. How do you play in the sorry, reveal myself as not a Windows user. F5. Well, thank you very much. Really so lovely to be here in such a diverse group of soundscape researchers. Really, really exciting. Thank you very much for the invitation. My name is Alice Eldridge. I'm a reader in sonic systems. I suppose I'm kind of hopelessly hybrid. So I work between sound and music, ecology and computing, and I've sort of switched around those perspectives. And I'm going to talk today really for the sake of those that aren't working in ecoacoustics, zooming right out and just trying to give a broad brush of the kind of some of the theoretical motivations, which I think are all shared amongst us, some of the theoretical frameworks and current methods. And I haven't even had a chance to ask him if he minds, but I am advertising Sarab's brilliant work here towards the end of the project. So the motivation, I think we're on the same page here. It's very clear. Biodiversity loss everyone's focusing on climate, but actually biodiversity loss is like massively in the red. We really need to act now. We're also here to talk about future funding, and at last we have huge opportunities motivated to do this, both nationally, across Europe and globally. We're now trying to act on biodiversity, both restoring and reversing loss. But of course we can't do that unless we can measure it, and that's what a lot of these amazing hardwares we've heard about in the first session have been aiming to do. What I'm going to talk about then is, I thought I was going after Stuart, so it was going to work perfectly. So we're going to go in reverse. So from bioacoustics, I think everyone here is familiar with bioacoustics. Understanding signals sent between individuals primarily is the focus, to ecoacoustics, which is a newer discipline which zooms out to look at the role of sound in ecological and evolutionary processes across scales, right? So including individuals, but also communities, populations up to the landscape scale. So we're interested then in understanding the soundscape as this kind of dynamic, emergent space, which is the space in which organisms both interact. So the soundscape kind of emerges from the interactions between biological, technological, and geological processes, and it also affects those processes, right? So it's this big dynamical complex system, and what we realize now is we can listen to the health of it, right? It affects ecosystems, but it also gives us a way to monitor the status of ecosystems. So some of the main kind of foundational theoretical framework for this is an evolutionary one. It actually comes from musician and bioacoustician Bernie Krause. Sorry, I haven't got a timer on there. You're going to time in. Comes from bioacoustician and musician Bernie Krause, who through field recording, listening to pristine habitats, choruses in pristine habitats, realized that the soundscape, thank you, is not a cacophony. It is in fact well structured, right? So he came up with the acoustic niche hypothesis, which is to say each organism has a unique spectrotemporal space, if you like. So that makes sense in evolutionary terms. If you can't hear each other, you can't mate, you can't avoid predators, right? So over evolutionary timescales, the idea is that species will partition. And sure enough, this is what we get. This was from a dawn chorus in Ecuador. We get this very strict partitioning of different species, and we see individuals turn-taking as well within a particular band. And a number of predictions follow from this, right? So we get species-specific spectrotemporal partitioning. Each biome will have a unique soundscape, and we can also expect, therefore, that higher biodiversity leads to higher acoustic diversity, right? And this is the foundations of our kind of first generation, well, foundations of computational ecoacoustics. This kind of makes a bunch of predictions on which we've built our tools. The other kind of framework, which is less well developed, but I think is actually also really useful for integrating humans with other animals, is a kind of ecosemiotic framework. So this is in flux. This is Almo Farina is one of the main proponents of this. It can be confusing because he's constantly chasing his ideas, but I think that's good. It's a sign of really deep thinking, right? So this kind of integrates information theory and biosemiotics at the landscape scale. So it's taking an organism-centered ecology. As our colleagues mentioned, we need to think about different species will have different perceptual acuity, right? So the soundscape then becomes this kind of space of multi-species semiosis, the space where signals are exchanged at the ecosystem level. So the soundscape is this kind of state of information flowing, if you like. So I'm going to talk about one of the methods we've looked at briefly, is which we'll come back to, is species ID. So that's kind of one paradigm, if you like. What we're looking at here is soundscape analysis. And some people have touched on this. There's currently two main ways to do that. One is what we might call hand-built or heuristic features. So first generation with very simple statistical features, things like even spectral centroid, zero crossing, measures of diversity, so simple entry measures in the spectral temporal domain. And we can see that these track diurnal changes. So this is about 28,000 1-minute samples from 3 different habitats: farmland, a rewilding site, and a pristine habitat in the UK. And sanity check, yeah, you can see these kind of indices track diurnal patterns. We can predict species richness, diversity, vegetation structure, habitat status in some situations, right? So those of you that have worked in this area will know these were attractive because they're really cheap, so great for real time, but they're crude. Interpreting is not always intuitive, but they can be surprisingly powerful in combination. I'm going to skip out. I think most of you can read a confusion matrix. This is UK and Ecuador, farmland, kind of monoculture, regenerating and pristine habitats, classified using the actual species present and acoustic indices. So these dark diagonals show us that if you can't read the out-of-bag error rates, the acoustic indices actually give us better classification error rates, lower rates than the actual species themselves, right? So the idea from the acoustic niche hypothesis that distinct biomes have distinct soundscapes, we can measure them, even with super cheap indices. So this was like 26 very simple indices bunged together, which supports the intuition that if we have higher dimensional features, even if there's some redundancy, gives us better power, right? And this work, which Saurabh has done was one of the first demonstrations of the value of using these learned features, is developing this further. So we've seen this pipeline. I think Becky's going to talk about this further, so I'm not going to go into detail, but just to say it works really well. That's enough. And Saurabh can and I think Lorenz was also on this on the later project. So we get really strong predictions. We can cluster by season, by site, by habitat status. And your more recent work showing brilliant prediction of actual species occurrence, even when you haven't labeled those data sets. So this is super exciting. Really promising for biodiversity monitoring and monitoring habitat status. Both of these approaches really build on the kind of evolutionary acoustic niche idea, right? And most of these approaches so far are taking individual samples and analyzing them independently, right? Discrete independent samples. But if we think about the soundscape as this kind of dynamic space of information flow, it feels like we're missing a trick, right? The soundscape is this emergent dynamical complex system. So don't we want to find some way to measure, maybe with Becky's amazing spatial arrays, the flow of information through that? And that's something I'm interested in at the moment. And we've got a very blue sky kind of hand wavy pilot. I shouldn't say that here, the funders aren't here, funded by UKAN, which we're very pleased about. It is quite blue sky, it's kind of high risk, working with colleagues at Sussex in neuroscience and complexity sciences. So looking at ways to measure using causal analysis and dynamical complexity analysis. So we're saying, can we measure the flow of information, if you like, through a soundscape? Now, intuitively, we must have measures like this must be useful, right? It feels useful. Will it work best in terrestrial habitats or in aquatic, marine, in freshwater, in soil ecosystems? I'm not really sure. But in this first pilot, we're having a look to see whether the statistical structures are present in these relevant data sets to see whether there might be some leverage in a kind of, not an alternative, but a kind of complementary paradigm to either species recognition or soundscape description to look at this kind of dynamical flow. So I think that's enough. Thank you very much.
Great, thank you. Has anyone got any questions?
Thank you. That's really interesting. I'm curious to know whether you see there's still a place for things like ecoacoustic indices with pre-trained networks being used. And if there is, how close do you think we are between finding a way to standardize that? Because I can see that's a big problem between comparing studies at the moment.
Yeah, I mean, I think we need all the approaches at the moment, right? Like ecologists don't just have one way of measuring biodiversity. And everyone said this from the word go in ecoacoustics. We're never going to have like one magic bullet that's going to solve everything. I think everything is going to be problem specific, challenge specific. So yeah, I mean, I think you're right. We don't even have a standardized like sampling protocol, right? So there's so much to do to create these baselines, to create standardization, which is something we're working on the workshops in June, not only for sampling, but yes, but for analysis. So yeah, I don't think any of these are dead ends. I think all of these have a lot of work to do still. Even those acoustic indices, I was amazed by how powerful they are. Even these like super zero crossing rate, like, you know, yeah, even super simple descriptions. So for me, it just says there's an awful lot of information in the soundscape and we don't understand yet. And yeah, I think it's really encouraging for all research in kind of biodiversity and ecological research.
Yes, please come to Manchester on the 15th and 16th of June and have really in-depth conversations about it. Any other questions? I think we still have a minute or two. Anything online? I'll just pass you there.
So this feels like a slightly naive question, but when you were referring to biodiversity loss and setting the scene, one of the things I've always struggled with is I can understand how we can measure and monitor these things retrospectively. So we can look back 5 years and go, oh shit.
Yeah.
Things are not going right. Is there a way to be able to measure that or monitor that on a daily basis so that we can see on a daily basis how well we're doing or how well we aren't doing?
Like an early warning signal.
It's not, I don't think we need the early warning.
Well, I mean,
it's more to do with, so for example, we measure, parts per million of CO, and there's some people that do sort of tweak that every day.
Yeah.
And unfortunately, it changes so slowly.
Yeah.
That it becomes less impactful. However, what's horrifying is that it just keeps on going up.
Yeah.
And I'm kind of wondering, from a biodiversity perspective, is there things that we could measure daily to kind of show that actually, hopefully we're heading in the right direction with some things?
Yeah, I mean, I guess there's probably other people in this room who are more expert than I to answer that. But yes, certainly. I mean, there's diurnal pattern variation, right? There's seasonal variation. So we can't know, we wouldn't expect from one day to the next, it's like biodiversity to like increment up like carbon monoxide, or carbon dioxide even. But yes, certainly. I mean, I don't know, Carlos, you look like you were. Yeah, so that's why we're all interested in long-term monitoring, right? That's why we need the batteries to last for a long time. We need to do monitoring over years. So a lot of this research, my personal interest, and I think various people here are interested in monitoring restoration programs as well, right? So we've got lots of anecdotal stuff to show that things are depleted, but in order for these restoration programs to work, we need to be able to monitor them. In order to raise more money for them and to build, for evidence. So it will be showing year-on-year changes rather than hourly or daily changes. If that makes sense.
I think that's where we're building towards, right?
Yeah.
We're trying to work out how to calibrate stuff still.
Exactly.
Understand short-term fluctuations well enough to do the long-term.
Yeah. I don't know if that answers your question.
Yeah, I just found it always really interesting that we say to ourselves that we can only look at it sort of 3 years down the line and look back and say, yes, no, that was what we thought.
Yeah.
And that we can't get some slightly more nearer term indicators that things are heading in the right way. Yeah, maybe not hours and minutes. I kind of get that, but monthly.
No, I think we should be able to. I just think the research base isn't there yet, that we know how to calibrate things accurately to understand whether the fluctuations we're looking at the moment are just short term or whether they're an actual trend.
It's like if you just started doing weather, right? The weather changes through the day, the weather changes through the season, and then you have like El Niños. So until you've got 100 years of weather data, you can't begin to understand those fluctuations. And it's sort of similar. We similarly, even with restoration, right, we don't really understand succession and how those things change. We might see change, but it might be someone was working on like invasive species. Then, yeah, there's so much we don't know. Yeah, sorry.
I'll go on quickly.
Thank you. Thank you. I guess I was sort of picking up on that. I was quite curious about this new blue sky project you were talking about, and maybe whether you had some thoughts about the kinds of signals or causations that might be detectable on a finer scale to understand a bit of that dynamical systems mechanics.
Yeah, I suppose I'm thinking about this both to say, can we have a kind of acoustic measure of ecological integrity, if you like? How well, so we think about ecosystems as resource flow, but shouldn't we, as soundscape researchers, we should think about it as sound flow, right? How well can these organisms communicate? And that's also a measure of like how well structured is that particular community, but maybe also thinking about a way of understanding the potential impact of noise pollution right? Because if there's a signal that's so strong that the other signals can't propagate, right, it's potentially a measure of that as well. Yeah, I don't know. Let's talk afterwards. I'd love to talk about it more because it's yeah, as I say, like a sort of hunch I've had for some years, and we really are just doing a very first look see.
Okay, thank you very much.
Yeah.
That's really interesting. So next up, we have Stuart Newson with a very different approach to identifying biological sounds. Lots of different taxa in the soundscape.
Okay. I'm very grateful for the opportunity to talk to you today. Just to give a bit of background, I work at the British Trust for Ornithology, and a core part of my work is on birds. But for many years, I've had an interest in bats, and particularly in the sound identification of bats. So a lot of my work is interested in species identification. It's really important for a lot of my work to know what species is declining, how it's distributed. So I've been involved in quite a number of projects, like this project in southern Scotland, which is deploying bat detectors, getting volunteers to deploy bat detectors over an area of southern Scotland of about 25,000 square kilometres. And as you can imagine, dealing with this data, the kind of volume of data collected through projects like this, quite early on, and this is going back 10 years ago, I needed to start working on machine learning classifiers to try and deal with the data, even though I'm a biologist first. More recently, I've been kind of scaling up to much larger projects. So this is a project I've been involved with. It's had to come to an end. It's in Ukraine and Belarus, focusing on an area of about 100,000 square kilometers. So lots of people on the ground deploying acoustic devices, collecting a lot of data for bats and other stuff that I'll come on to. And more recently, we're expanding even further and supporting projects, acoustic projects for bats and other species groups across Europe. When you put out a bat detector, we quickly found you record a lot of other stuff as bycatch. So bush crickets, you tend to get more bush cricket recordings than you do bats when you deploy a bat detector, which a lot of bat workers really hate. But there's a real opportunity here. Bush crickets are fairly poorly monitored in their own right. So I started, having built bat classifiers, I then started building in bush crickets to identify those where they're recorded as bycatch during the bat surveys. The next species group, I realized that you also record the high frequency calls of small mammals, which are again recorded as bycatch during bat surveys. And the first thing here was to try and provide a paper, accessible paper, to describe the sound identification of small mammals, firstly in the UK. So this British wildlife paper was the first attempt to describe the sound identification of many species of small mammal in the UK. But again, having built a big reference library of recordings covering all UK species, I could then build those into my bat classifiers and bush cricket into the same classifier as the bush crickets. And it kind of grew from there. And I started to kind of build in some species of the moth that produce high frequency sound. So the idea was to try and record, even though my initial focus was bats, trying to get as much from the data as possible. More recently, colleagues of mine at the Bto have been working on deep learning classifiers for a range of bird species. At the moment, we've been focusing on nocturnal birds and then working on trying to build these into a pipeline to make these classifiers much more accessible to lots of people. So my kind of real interest is in large scale citizen science and dealing with these large data sets. And to try and deal with this, we set up what we called the Bto Acoustic Pipeline. And what we wanted to do was people would collect data in the field remotely, be able to upload the recordings to where we wanted them to be processed in the cloud, and then for the recordings to be processed and for the user to be automatically emailed with the results once they've been processed. So just to describe the Bto Acoustic Pipeline, there's two parts to it. There's a desktop app, And this manages the uploading of recordings. And if you've got a location embedded in the WAV file, it will pull that out. Otherwise, you kind of set where the recording was carried out. And with this, the pipeline uses the location and automatically pushes it through a regional classifier. So if someone in Belgium uploads recordings, it'll push it through a classifier that I built for the suite of species you've got in Belgium. We've got a few, so this covers Europe and a few other places like Tasmania and a few kind of random places. There's user account, so the user can log in and look at their data. We could also set up projects where people can upload, users can upload to a project. And by doing this, you could have hundreds or thousands of people uploading recordings to the same project. And the project organizer can see all the results as they're being processed. There's also some interpretation and visualizations of the results. So this is just an example of, it's actually time in the night that common and pygmy shrew are being recorded on bat detectors, but it's just an example. But there's kind of maps where you can view your data, where different species were recorded. So we launched this the beginning of March 2021. We've had about 1,000 users, but they've uploaded about 50 million recordings, and there's been about 32 million species identifications. But I think this is something, because it's in the cloud, it's scalable. If we need more processors, we'll add those. The other thing we need to think about, so I work for a conservation organization where my kind of real focus is supporting conservation projects, but there is a cost to cloud processing and storage, and also supporting users. So the approach that we took was what I call freemium pay model, where it's free to use up to a certain limit. And this is equivalent to about 50 nights of bat recording, 100 gigabytes. But users, they're encouraged to share their data, and if they agree to that, then they could use it at a discounted rate, subsidized rate above that kind of limit. Where it's really important that the data remains confidential, so for commercial projects, so for example, environmental consultants working on infrastructure projects, there's a higher cost to use the pipeline. And the whole thinking is, by doing this, we're enabling the kind of long-term viability of the acoustic pipeline. And after the first year of running it, we've covered our costs of in providing our cloud costs and support and some development time. So I'm just going to end there, and thank you for your attention.
Yeah, it's really interesting. Such a large scale of citizen science data. Does anyone have any questions about that? I think it's for the Zoom viewers, so they can hear you.
It's going to be, so initially it's going to be a suite of nocturnal birds, so starting with owls, nightjar. So this is kind of a European scale, so European owls, nightjar, woodcock. And then we're going to add in nocturnal flight calls, and then hopefully kind of build up on that. But initially it was bats, and then kind of adding in all these other stuff that are recorded, that kind of high frequency, so bush crickets, moths, small mammals and bats. Okay, so that's really my interest. So for bats, what I do is I spend a lot of time, the whole time, kind of collecting data through my projects, also collecting independent data where I can be sure it's that species, and continually testing, and where there's errors, I kind of feed those back in. So it kind of improves over time. But there's also dedicated papers on the classifier performance for bush crickets. one for bats coming out soon, small mammals, hopefully at some point. But one of the issues is you write the paper and it's published, and then you've then spent another couple of years working on the classifiers, and they're kind of better at that point, hopefully. It's really any full spectrum bat detector. So it's really to support any projects. So there's a lot of audio morph users, but then there's a lot of people using commercial bat detectors as well. No.
Okay, brilliant.
Okay,
Thank you very much. And final talk of this session is.
Okay, so this time I'm going to talk a little bit about what I did more towards the start of my PhD, which is how we can manage soundscapes, or rather soundscape data, with things like compression. So I'm going to talk about why we might need to do that, possible problems with it, and ways that we can work around those issues. So first off, as I'm assuming most of you know, soundscape data can quite quickly get really large. So to get like a CD quality audio, just single channel, you're getting about 7.5 gig a day. If you had, say, a basic study with 5 recorders, for 1 month, that's a terabyte. We're talking about long-term monitoring, so you can imagine as months go on, though, it's going to get really enormous. Hosting, sending, particularly as we're hoping to do autonomous work, sending that stuff over networks, it can take a really long time, but it can also be quite expensive. So some people people can and do use compression to get around that. So there's two main kind of ways of doing compression. The first is lossless compression, which works by not removing any of the data, but rather by reducing redundancies in the way that the data is stored. So you can generally compress a file to about 50% of its original size without losing any actual information. The other way of doing that is lossy compression. So this was designed mostly around the human listening experience. So things that humans aren't able to pick up on, certain frequencies, certain things that are masked, are actually taken out of the data. And if we do this at a really, really high rate, we can get that down to just 1% of original file size. So you can imagine that's quite a big saving in terms of cost and data storage. So a lot of the time, as it's designed, as I said, it was designed around human listening. When you listen to two signals, one that isn't compressed and one that is, they can sound very similar. I think you'd have to be quite a well-trained listener to be able to pick up those differences. But when you look at the spectrogram, you can see that actually quite a lot of information has been taken out of that signal. So the question for us is whether that information that we're losing is actually ecologically relevant information. So I set up a little experiment to see if that was the case. So yeah, as we've mentioned, there are sort of two main routes in doing whole level soundscape analysis at the minute. Those are those custom built, specialist designed indices that are designed to pick out certain features that are indicative of a biodiverse area. And then there's the machine learning based fingerprinting approach. This is the audio set that's been mentioned a couple of times. Basically, it's a huge network that was trained on loads of data. And we're using the final, there's a feature layer, which is just essentially 128 numbers as a kind of abstract descriptor of that soundscape. So you can imagine it a bit like a fingerprint or a barcode. The experiment itself, we took recordings from very different areas in the Bornean rainforest. We compressed it across a huge amount of rates, well, no, a few rates, and then we extracted both the audio set fingerprint and the indices. To test whether there was an effect, we did like-for-like differences. So we compared, one audio sample, we compared the raw to all of the data from all of the compressed levels to find the actual value difference in the indices. And then we also had a look at classifier accuracy. So we then, for each compression level, trained a random forest model and saw how accurately it could actually build a predictive model for where those sounds had come from. So we present the difference as a percentage of the range. So that's just because a lot of the acoustic indices are actually on very different ranges. So if you put it as a percentage, it makes it comparable. And based on literature, we call a significant difference, or one that we should worry about, as one where the median value is outside of 5% of the range. This is the difference. Or one where the standard deviations don't include 0. So what we found first of all was that there was the audio set you can see up top. There's really no detectable difference until about CBR 16, which is about 4% of the file size. So no detectable difference. We also see in other of the acoustic indices that we're not really getting a difference until we've got really, really high rates of compression. Looking at other indices, those changes happen a lot sooner. And what's quite interesting in these two is that so beyond CBR 64, the actual maximum frequency gets reduced. And as we reduce the maximum frequency, the accuracy can tend back towards 0, which we talk a little bit more about in the paper. And then finally, you've got other indices that are very much straight off the bat, really dramatically affected by even quite high rates of compression. So yeah, basically the main part of that is that there is a big difference in the way that indices and the audio set fingerprint respond to practices like compression. And that audio set is actually performing well in this case. We then looked at the classifier accuracy. We did a few other tests within this study, so apologies if there's a bit more than expected going on, but basically what we found is we're confirming a lot of prior research that audio set is continuously outperforming the analytical indices, and that compression actually has a much smaller effect on classifier accuracy than, say, choosing the index selection. We also find that, we also wanted to have a look at downsampling, because what some researchers will do is they'll say, okay, the dawn chorus is a really active period of the day. So what if I just record the dawn chorus, then I can have a study over a longer period of time. So we segmented the day from, I think it was, into quarters, right down to little 2-hour segments. So what we found was that the model that was trained on literally just 2 hours of data and tested on 4 hours of data, we're getting for the audio set accuracies above around 70–80% for all of the levels of compression. But for the analytical indices, that does start to fall off and become a lot less accurate. Based on that, we're able to sort of provide some advice for people that want to say, reduce their data storage problems, but also maintain the amount of information they can describe with the indices or the fingerprint. And I guess the main take homes is that we've shown, again, that audio set is not only more accurate, but also more robust to things like different timescales and also different levels of compression, different recording styles. And that factors like compression can be used if the right questions are asked prior to using it. Thank you.
Thank you. That was really interesting. Just see if this is working again yet. Okay. Does anyone have lots of questions? We'll start with Alice.
Thank you. Thanks, Becky. It's really interesting study and really worthwhile doing. So thank you for doing it. I had a question around, so not seeing the differences in audio set, it's kind of not surprising that it's more robust. That's great. But do we know that audio set is just what audio set is discriminating on is ecologically relevant?
So that was kind of where we use the classifier task as a sort of proxy for that. So the classifier was built to distinguish between different types of forest. And the thought behind that was, okay, we might find that we're losing loads of, or like the indices are actually being changed a lot. But if we're still able to get the same classification accuracy, well, then I guess it's not super important that those differences. So in our experiment, the classifier was used as kind of a proxy for whether that data was.
Yeah, but I suppose my point is we don't really know yet, like what deep learning is discriminating on. In Bob Sturm in Music Information Retrieval did a really nice paper called Detecting Horses. That clever hands the horse that looked like a count, but actually was picking up cues from the interviewer, right? So you can get confounds where what the model is picking up, the differences the model detects might not be the differences that are relevant to the ecological question of the organism, right? So yeah, it's a great experiment, but I think it's a question for us all to keep in mind.
Yeah, for sure. And also there is a sort of word of warning with that study, is that the sites that we used to get that audio data are very, very different. So there's quite stark differences between them, which I think would make that classification task a little bit easier, which is why I kind of opted to use the differences values as a more, okay, well, like if there's no detectable difference as a result of compression from audio set, then I guess we can still use audio set with compression, if that kind of makes sense.
Carlos, did you have a question?
You mentioned that higher frequency being lost more with some phases of compression.
Yes.
And what frequency range you looked at, and if you're interested more in bats, for example, would there be differences to your data?
So this was all audible range. For this study was all audible range. I think, I can't remember exactly, but I think the maximum recording the frequency that you could hear in the signals was reduced down to about 4 kilohertz, I think, at the maximum compression rate. I might have to check, like dig up the paper to get the exact value for you, but yeah, it was all audible, nothing beyond that.
I wonder, I mean, the compression model of the compression approach is I'm going to try actually.
Yeah.
Just want to add one quick thing that was interesting related to what we mentioned before about human consumption. I think this was a study where we looked at a human developed algorithm. MP3 is done for removing data that are not audible. And we just started looking at how this affects something that is not related to human hearing, but is related to classification maybe, or to other ecologically valid matters. So I think the discussion we maybe started before, and hopefully we'll talk more later about what is Soundscape, if it's for human or not, I think is very relevant here. And we're now moving to the third session of the morning, which actually talks more about the human side of things, I'd say. So,
oh, okay. Okay.
Cool. Then we can move on to the last session. We are late, 15 minutes about. I think we should be
quite quiet,
able to catch up.
Oh, sorry.
Yeah, that's third session. So when we organize the workshop, we thought we would pick up some key challenges. So for this sake, because there are a lot of work done in soundscape research, but also in practice. But we thought most challenge issue is how to move from research to practice. I think this fit well with the previous two sessions because a lot of research work has been talked about. But for third session, we focus on practical need, policy need. So that's why we invited speakers from what industry or academic people call industry. We have Ben from UK Health Agency and Julia from Environmental Agency. And we also invited DEFRA, but DEFRA colleagues can't make it because of date clash. So these are the policy side. And also we invited two practitioners from engineering design side, Barry from Holy and Adam from Arab Acoustics. And also we have NGO, Lisa from Noise Abatement Society. So I hope this gives you a big picture about what's needed from practice. So it's other end of the soundscape. So we put all this together. So each speaker will speak and with different color. You have green color.
So thanks, John, for the invitation. It's a pleasure to be here. So I'm Ben Fenech from the UK Health Security Agency, and as you can imagine, I'm going to focus on the health aspects for humans. And because we're talking about soundscapes, I thought where best to start than the definition of soundscapes in the standard. I'm going to skip the first bit, the acoustic environment. We heard a lot about that in the first two sessions, and I'm going to focus on the rest, and I'm going to break it down into three chunks. I'm going to talk about a person or people. I'm going to talk about the context, and finally, as perceived or experienced and or understood. So started with the first one, a person or people. So if we look at the sort of the history or how we did noise management to date in this country, it's primarily based on the average person or the average response. And that one way of looking at it is we're treating people equally. So we can talk about equality. And that might work great for some people. It might be okay for many others, and it will be completely inappropriate for some. From a health perspective, it's much better to talk about equity, where we focus on giving people equal opportunities. And yes, that does mean that sometimes you have to treat people differently according to their specific needs. The second point is about context. So context is the buzzword of the last decade in acoustics. It appeared in the noise policy statement for England. It appeared in BS 4142, which we'll talk about, and also in the Soundscape standard. Obviously, I'm going to talk on the health aspects, but all the speakers in this session will talk about context to some extent. So we know that some sounds in certain contexts lead to ill health, and some sounds in other contexts lead to good health. And some of that is dependent on personal characteristics and something we call coping capacity. How well are you able to cope with the stimulus or stressor? And if you have coping resources, if you are able to cope with it, that's good. If you have coping deficits, that's bad. But there's other things which determine our health. There's lifestyle factors, there's activities, there's social networks, there's the built and natural environment. These are equally or sometimes more important determinants of health. We call them the wider determinants of health. And my ex-colleague and I did a review which showed that the sound environment is linked to all these domains. And that's very important because when people are making decisions, they're not making decisions based on sound in isolation or on lifestyle in isolation. They need to take all these factors into account. So if we have sound linked to every one of them, that gives you a much stronger position in the decision-making table. My last point is on the bit as perceived, experienced, and or understood. And as we've heard earlier today, there's been a lot of brilliant work carried out on the outdoor environment. If we consider noise management and noise assessments, they normally stop at the front door. It seems like we've been hesitant to get into a building. And yet, from a human perspective, we spend most of our time indoors. So it's very important that we move beyond the outside environment, inside the environment. And when we do that, it's very important that we don't consider empty buildings. Buildings are there to house humans, and humans have behaviors which in turn change the sound environment and change other environments which are also linked to their health, indoor air quality, temperature, etc. So to try to wrap up and bring all those three things together, from a health perspective, there's a lot of interest in designing and creating compact neighborhoods. So compact neighborhoods are good because they promote active travel, they're good for social cohesion, and they're good for the local economy. But if we want to be there on the table, if we want to have a strong voice in the decision-making process, we need better evidence. We need better evidence how the total sound environment affects our health, not just the relationship between road traffic in isolation or rail traffic or aircraft level, is the total sound environment, and the links, as I said, between the total sound environment and the wider determinants of health. We need better evidence about the indoor sound environment and health, and also how the indoor sound environment change healthy behaviors like ventilation behaviors. And finally, we need to realize and recognize that that's not a row of houses. That's 7 individual dwellings with specific needs. And of course, I'm not going to argue that we need 7 different policies for one for each dwelling. But I'm going to argue that we can design interventions that take into account some of those different needs, and thereby leading to better health equity. Thank you very much.
Quick question.
Where's the micro? Oh.
Thank you so much. Just a quick question. When you talk about health, do you also consider mental health? Like, I think it's a very important issue in recent couple of years.
Yes, absolutely. I should have perhaps defined health. Yes, it's recognized health is physical and mental health and well-being. Yes.
Any further question? I think we can always come back if you have an overall question for the session. So thank you, Ben, again. Yeah.
Yeah, it's coming. Thank you so much. Just a quick one. In this my quick talk, I will try to represent you how decision makers, sorry, not regulators, and particularly Environment Agency, where I work as a noise advisor, how we deal with soundscape. And one soundscape, I just want to clearly make sure there is a clear definition in the standard what soundscape is, and I think we need to stick to that one. Maybe for bioacoustic, we need to develop another term possibly. So I'll briefly talk to you about BS 41 and 42 standard. I don't know if many of you are familiar, and context. Then how soundscape and context go with regulations. Briefly touch on 2 environmental agency case studies where context and soundscape has been important issues, and conclude my presentation. In terms of BS 41, 42, for those who don't know, it's a standard for assessing rating assessing industrial commercial sounds. It has been since 1960s, but the most recent version is 2014, with some amendment been done in 2019. And this is a standard to identify impact of noise impact from industrial commercial sounds on people, we call the nearest sensitive receptors. And this standard is required by the Environment Agency for identification of impact from all permitted sites. In a quick, briefly, in BS 41, 42, typical background sound level, SL19, is subtracted from rating level, which is measured in LEQ, to identify impact. And rating level is a sound from a site and the nearest residential receptor, with added correction features like tonality, impulsivity, other intermittency, and other acoustic features. And impact is, there are 3 categories of impact. Is the rating levels below the level is 10 dB above the ground level is significant adverse impact, 5 dB above the ground, it adverse impact, indication of adverse impact, and rating level doesn't exceed the ground level is indication of low impact. But this is all depends on context, and context is a problem that we've been dealing with. We can see applications from for new permitted site that need noise impact assessment, and they are supported by acoustic consultants reports, which is the acoustician writes them, and lots of them either don't take context into account or are identified completely in the wrong way, which obviously can be deliberately, but some people just don't know what this is. Lots of engineers don't really know what context is. I'm sorry to say that. Not saying about engineers in this group, of course. Recently, the Environment Agency published a new guidance, formerly known H3, but now it's a name, Noise and Vibration Management Environmental Permits, and actually it's published in 2021. And Soundscape assessment is a new chapter called Soundscape Assessment, where we emphasize that Soundscape is a multidisciplinary approach, and assessing and predicting soundscape quality is an important part of assessing context for a noise impact assessment. And we particularly mentioned that ISO 12913 series standards should be used for if someone uses it for assessment, if someone decides to use soundscape assessment for identification of impact. Briefly tell you about context and soundscape now in our cases. So the first case, it's waste processing site. It's actually a soil processing site. So there used to be proper farm, but now the new owner decided to process soil, mix it with some rubbish from concrete site, like construction sites, and just rubbish and then sell it like soil. And so they use some machines which are completely atypical for the rural environment. And since opening in 2018, since the Environment Agency granted a permit, there are lots of complaints because of noise. Several noise impact assessments been carried out by several acoustic consultants, and also Environment Agency carried out a noise impact assessment, and we all identify significant adverse impact. It was not possible to reduce noise from site to acceptable levels, and therefore the Environment Agency issued a notice of revocation to permit. And there was court hearing in December where we were served as witnesses, and in 2022 January the appeal was dismissed. And the main factor of decision of planning inspector was context. So it clearly said that this site is not suitable for this sort of sounds. They were completely atypical. And second one is where we apply, the second case where we applied actual ISO 12913 standard method C for identification of impact. So this site, again, waste transfer station, is actually located in a very affluent environment. It's near London. I can't tell you where it is. It's not very quiet actually, because there is traffic. There are airplanes passing through. But the newly waste transfer station introduced completely out of context sounds, like trommel sounds from trommels, and also deliveries to the site. And the context is very highly sensitive residential area. The expectations from the area is high, and there were lots of complaints for these sounds. We carried out our acoustic measurements, and we also carried out our soundscape assessment. And the residents, I'll show you the next one. So this is specific sound level map when we built based on our acoustic measurements. So what you can see, those are responses. We've recorded 17 responses for our soundscape questionnaires. And you can see the residents are arbitrarily numbered. They live between 10 and their level specific sound was between 50, see here in this area, and here was 40 dBA, and then the ground was, we measured the ground 41 dB, but in this area possibly there will be much lower ground sound because the roads are somewhere here. But what surprisingly, all the residents responded that they all could hear the sound from site. They were all annoyed about it. They were all blaming the sound from site, from trommel and deliveries, for all bad things happening to them. So it's just what the site demonstrates, that without the proper consideration of context. It's when you introduce something in completely in environment where the sound is something new, depending of course on residents, we need to do this assessment, particularly acoustic consultants. They need to take into account all stakeholders who might be interested. So just conclusions. In BS 41, 42, we identify that context is application soundscape approach could be useful for identification of context. Context important for noise impact assessments. And we, in the newly published guidance, Soundscape method advice for assessment of context. Based on our previous studies, we found out that some other descriptors might be useful to be developed, like appropriateness and acceptability of industrial sounds alongside their visual appearance. And we believe and we recommend that Soundscape approach is possible method for assessing soundscape during permit applications, auditing, or assessment of complaints. Thank you.
Any questions? I realize this is quite a different kind of scale.
It is a bit,
aspect, but that's what this workshop is about. For people, the industry side.
But we're very interested in, as I mentioned, we receive lots of permit applications where we need to, not we, because I'm working in different environment, but people who assess noise impact, they're completely blind, they don't know what to say. And there is, we have in our permit conditions, you need to assess site for biodiversity, for impact on ecological receptors. And it's just, I don't know, it's like that. You know, you put your finger up and which direction wind blows. There is no guidance, but I'm happy to talk to other people later. Thank you. Yeah, go on. BS 41, 42 just applied for human receptors. Yeah, we don't yes. No, really, no. It's they all wanted to close the site. Yeah, it would be useful to do let's say binaural or recordings in those locations, and to actually notify if anything they could hear. But when we walked on through the site, you could hear you could hardly hear the noise from industry because of so much traffic in the area. Because I think preconception and with very strong community, what actually it's Ben said before, community, it's one of those things that can hold people strongly together, and they will all either like it or hate it. And that area particularly was very interesting because most of the people lived there for, I don't know, some of them lived like all their lives, someone just moved in, but they all had the same sort of response, which is quite unusual, per se. We applied method C for 12193 questionnaires. I'm actually going to publish a paper in Internoise based on that, and we use QR codes so you could scan it. And if you're going to attend, or if you find that paper, the questionnaire is still there for people to look at. Obviously, you can't answer them, and it's not identifiable anymore because it's very confidential. But they also added some questions particularly related to the site, but mostly method C. Just like, so, yeah, sorry. Sorry.
next speaker is supposed to be Barry Joblin, but he got COVID this morning. So after some communications, what we decided is he sent me some text. I'll play his slides and read the text. Hope this will work. Yeah, firstly, his apologies, he can't make it, but he feel okay. That's why he put some text. And he wants to give a short story about a recent project, because Holy is, as you know, is engineering company, and they do practical project about soundscape or acoustic design. And he was actually quite surprised at how interested and keen the client was, suggesting that Soundscape could potentially even be a USP and help with community engagement. He hoped the story, he hoped that the story might offer encouragement to others. So this slide is just a statement of the originator of Soundscape. I think this opened a big debate about what Soundscape is about. That's original one, and then there was ISO standards. But that's a long story. We don't talk about that. That's my words, not Barry's. And slide 3 is very structured his story in 4 parts as follows. It's 4 parts. And the opportunity presented itself when appointed as the acoustic consultant on a major mixed-use project, regenerating a town center, developing over 300 new homes and a range of other spaces. The architects laid out their design vision for the scheme based on 6 design pillars. Barry would have explained more, but essentially he spotted 3 pillars where the sound environment could play a part in developing the design. They wished to introduce different type of spaces, and in particular green, healthy zones, and also more vibrant, active entertainment areas. And the architect talked about the prospects of bringing more green spaces from the surrounding areas, including local parks. And Barry thought this was the perfect opportunity to not simply do the usual of keying the unwanted noise out, but to look at how we might also bring in good, positive, healthy sounds. And next on the pitch of the client and the team. And they started by simply comparing noise and the sound. And for some in the room, this was a real eye-opener, or perhaps ear-opener would be a more appropriate. It was very simple, but effective in opening thought of lay people. And has to be one of the best quotes ever, says it all. I just read his slide, I don't say anything more. The pitch to the team was to consider something different based on some extent on emerging research. They explained that there was a new movement away from traditional method of numbers-based compliance design to approach more focused on user perception and experience. And they float how a sound work can assist with identify desirable or undesirable acoustic characteristics to incorporate within the design. And they posed the potential, discussing with the team how they might use the findings to enhance the design of this regenerated area. And it did not take much convincing for the team, including the project director, to join the sound work. And they actively listened and engaged in the process. For us, there wasn't any major surprises. And although there were some interesting variations in opinion, for example, loudness is not necessarily correlated to quality. And the findings, if anything, affirmed what might be expected. This is simply a summary of some of the observation of likes and dislikes. Hope you can read it. And so to close to the experience so far, the first point to note is that soundscaping is being considered wholly pro-positioned, how the findings of the sound work could be used to actively manipulate the existing soundscape for the better of the development, join the good in and keep the bad out. More generally, Barry wanted to raise the viewpoint that they felt were important in the success of this story. They had ambitious and innovative client, developer, and team, and with the right pitch, they had curiosity and appreciation of the proposition, and they got actively engaged to understand and adopt. Thanks. Hope this is a story you get. Hope that's Barry. We don't have opportunity to answer question. So our next speaker is Adam from Hyperbolic Acoustics. Again, another practitioner from engineering company. Adam.
Thanks. Thank you, and thanks, Andrew, for inviting me to be here. I'm going to start with a disclaimer in that my slides are all about designing for human perception, essentially. But everything I've seen this morning is really brilliant, and I think it's got great importance. To give an example of that, a couple of weeks ago, we've started a project looking at public perception of drone noise, and we've engaged with a few stakeholders on that. And one of them is a very well-known government body. And the first question back to me, they said, was, what about other species? Okay, so it's very much on the agenda. And if we can work together on that, that's great. So my slides, I'm going to go through it on quite a high level, just to sort of give a perspective of maybe what the challenges are in terms of, bringing soundscape into our design. So I'm going to reflect quickly on where we are now, give a few example projects, at a very high level of, what they do in terms of data capture. Talk a little bit about an internal research project that we're just starting on, which is relevant to this, and then focus really on, a few provocations. What are the challenges in soundscape design practice? It might make me unpopular, hopefully not, and also just reflect on a few things that might help, okay, to bring it into our sphere. So where are we now? Well, obviously there's research, which is huge and going really well. So if I put my sort of teacher hat on, I'd say, very good. That's great. It's very diverse. It's growing at an incredible rate. Policy is a little bit behind, I feel, in terms of international policy and global policy. Apart from some in the UK is certainly leading this. And Martin, I think you deserve a gold star for the Welsh government. It's certainly a document that we use internationally to showcase what can be done and that sort of forward-thinking future of it. In terms of design, yes, there are some good examples out there for sure, but I think I'd sort of must try harder, really, and the reason for that is it's difficult. What we're really talking about here is designing for human perception. Okay, so one thing is designing for the physical work, but actually designing for human perception has some other challenges associated with it. So a few case studies that I'll flick through quite quickly. Okay, the first one is a tranquility assessment framework. This project started about 3 years ago, and it's a collaboration between us in acoustics and a historic environment team. We basically applied the Soundscape ISO approach to assessing some historic assets in London. When that project finished, we did some multidisciplinary engagement, and now we're looking at rolling this out and applying it in terms of environmental impact assessments. So really assessing the human perception as part of that process, because previously they've looked at noise levels only, really. Another one is the nighttime vulnerability assessment. This is obviously, we want to design spaces in cities for people to be safe, but the perception of safety is a huge part of that as well. And also the perception of social presence. So we're looking at qualitative and quantitative data captured there, as well as some objective data as well. Fitzparklet is a sort of unique case study, really. It's a place in Fitzrovia where we put in a temporary installation of green infrastructure, and we were able to monitor it before and after. There's actually been 2 other sort of temporary installations that we've employed in London recently, well, more recently than that particular project. And it's very much been a case of let's measure it before, let's measure it after to understand that, okay? And similar to that, this is a project done in Leicester Square, but we're also deploying some AI now to observe behaviors and identify what things are doing and where they're moving and so on. And linking that up to a noise sensor, sorry, a sound sensor network is, you know, on our agenda as well. So there's a lot of threads there, obviously, and we're making some ground, but what we're currently working on is trying to join this together to make a framework of how we can actually interpret, you know, human perception data and importantly, use it in design, okay, which is a bit of a leap, I feel, that we need to take forward. So the next 2 slides, well, the first one's about the sort of challenges, and I want to frame these as maybe discussion points, maybe provocations, and very much focused on the human perception of design and the ISO. Firstly, resource. I think it's fair to say that gathering soundscape data is more resource heavy than maybe gathering noise data. Give you an example, I could deploy a noise logger. I could get one of my engineers to go and set it up near the office. They could leave it for 3 days, spend another hour collecting the data, and within a couple more hours, they'd have a pretty good picture of what the noise climate is in that area, okay? To do the similar exercise for Soundscape, we might need to go and set out 3 people to go do questionnaires, maybe for 3 days on a site to get a statistically significant sample, and then interpret that data everywhere as well. So there's more time, and there's, you know, more cost associated with that. And I mentioned this in, you know, in the truth of we're going to clients, we're asking them to do this sort of thing, but ultimately, you know what I mean, someone has to sort of become involved with this process and pay for it, okay? Secondly, the skills and experience. A lot of acoustic engineers come to us with degrees in physics, you know, masters in acoustics, and actually the soundscape skills that you need are quite different to that. And there's a bit of a learning curve taking them on that journey, or just employing different people, okay, to do that. So it's not that people are coming straight out of university with those skills necessarily, or maybe we need to just diversify where we're recruiting people from. Thirdly, it's about time, and at risk of saying the most obvious thing of the whole day, sound and time are intrinsically linked. It depends on that dimension, and sonic environments change over time. But also, and I think this is quite important, people's preferences and attitudes and moods change over time as well. And it's not completely certain whether we'd measure the same responses from individuals in different places at different times. And lastly, but actually probably most importantly, I think, is inclusive design. How can we design the built environment for everyone fairly and consistently? I don't think this is just about oral diversity. You know, we put a lot of effort into designing the built environment so that it's accessible by everyone in a physical sense. Looking at a perception response, it feels even more challenging, actually. Okay, so I feel that there's quite a bit of work to do, you know, to get us forwards in that area. And lastly, I'm going to just put some things out that maybe could help. And I'm sure a lot of these are on their way as well. But just to sort of touch on them really, congruent evidence bases, you know, strong evidence bases that we can use and pick up and show to clients and developers and, you know, prove to them that there are systems that work. There's obviously huge amounts of research out there very vast set of contexts as well. So maybe if we hone down on some context-specific areas that are really key to the built environment, maybe that would be a good way for us to take that forward, perhaps. Secondly, predicting things, really, prediction methods or design methods. How can we model it? What indices can we use? How do we look at big areas? We use oralization, obviously, a lot. I run 3 sound labs in the UK, and we've got more in Europe as well. And we do that in day-to-day. And that is one very good way where we can show people environments and take them through it. But that tends to happen in a smaller group setting, generally, just by the nature of, you know, our ambisonic suites and our listening rooms, etc. But, you know, if we want to trial designs and see what works and fine tune them, maybe some tools that help us in that direction would be useful. And lastly, a lot of people have spoken about context, and I won't go into it in any detail here, but it's a big subject and it's a big variable. And I feel that, you know, it's difficult to deal with because it changes a lot. But maybe there are, like I said before, maybe we could recognize context of certain situations and settings and actually group these together to get a better handle on that and to take it forwards in terms of design for perception. And that's it. Happy to take questions, but.
I suppose to raise the question of the challenge and what's needed.
Okay.
You can read it? Yeah.
So the first one is from Soundscape. It says, "Hi Alan, very interesting presentation. Interesting, you mentioned how you assess the Lossless soundscape by AI. Could you please comment on that a bit more? I'm just curious if that means some sort of automation or automatic data plans."
So there are kind of 2 things nestled into that method. The Leicester Square project was very much a before and after, where we went out and deployed people to observe people in the environment and do some questionnaires and so on. Linked to that, and I kind of jammed 2 projects into one slide here really, is something that we've got where we use we record video essentially and are able to, through AI, to identify objects and see what they're doing. So just movement of cars, scooters, bikes, people, etc., and track their movements over time in a place so that we can basically heat map it and see what people are doing in different areas and try and assign them to meaning like social activities or so on, or movement. So it's quite early days in that one, but hopefully that suitable. Okay. Got one more. Yep.
So this one's from Peter, and it says, "Do you see a role for personal wearable tech to pick up biodata that might be measuring perception?" So beyond this question. And in terms of that, it says, "You mentioned maybe you should be recruiting different skills. What do you
Okay, quite big questions. With regard to biotech, yes, I think there is a place for it. I think it's quite challenging. I did a project back in 2018 with the University of York, actually. I know Gavin's here with an ex-colleague of his, and we were looking at people's response to sound and how we can measure that response with wearable technology, but also with an EEG. And we were doing this in a lab-based setting. We learned quite a lot through that, actually. We learned that it's difficult to start off with, and there's a huge amount of variance in a lot of the sort of the signals that some of these biosensors wear, like heart rate variability, etc. Do you know what I mean? Have they had an espresso? You know what I mean? What happened to them? But there are some promising areas like GSR, galvanic skin response. I think that's something that we're really interested in, and we're developing more. So, sorry, what was the question? I'm sort of rambling a bit here.
So, yeah, it was just, do you see a role for wearable tech in the perception of soundscape?
Well, it measures a biological response, you know, a physiological response predominantly. So it's hard to interpret that as a perception, to be fair. I think there's we've got to treat it like a slightly different data set, actually. Okay. Perception typically be self-reported from people. Yep. Cool.
So the second part of that is what skills do you need to improve?
That's a very loaded question. I mean, I work in the acoustics team, but actually I'm sort of floating out towards more technical services, and this covers lighting, inclusive design, much broader field. I personally and professionally feel that, we need to design holistically. I think there's a natural tension whenever we design something in the built environment between different disciplines. And, I actually believe that really good results come from that tension when you work together. So I actually think we need to employ a really diverse skill set, actually, as much as possible. We're certainly not just looking at grads with physics degrees from here. We're employing quite a range of people. Hopefully that's okay for them. There's one from the room.
Yeah.
Hi.
Yes, following up on that question.
Mm-hmm.
How do you see Soundscapes getting integrated with sort of planning policy, green infrastructure, and design codes and that sort of thing in future years?
How is it going to be integrated into planning policy? Well, I think the policy is coming out. Martin's written some policy that we're using. I think some guidance is needed to follow. I think, designing for perception is difficult, for sure. And there's quite a lot of work that needs to be done to fully understand that. I think it's going to be very project specific to start off with, to understand the context and the community and what's the DNA of that community, so we can take that work forwards. But I feel that if we're going to roll this out at scale so that we can see it being, as much used as, say, BS 4142 in terms of noise assessments, it needs to integrate into planning policy. But at some point, there needs to be a decision of, is the soundscape assessment suitable for this site, right? Do you know what I mean? And what type of soundscape assessment is suitable? And at that point, they can be enforced into areas where it's going to work and where positive change can be made. Because in some areas, it might just be there are bigger fish to fry, right? There's a huge noise problem, which is causing massive health effects. And, really, we need to tackle that in certain areas.
Because there's the new guidance that came out from the Landscape Institute last year, wasn't there, on soundscape design? Has that been taken up much yet?
There is some guidance from the Landscape Institute, and I know it's a topic that they're very interested in. I was on a panel discussion with their CEO, and I'm going to forget her name now really badly. But yeah, and we were discussing soundscape design and how that can be used in terms of safety, along with lots of other things as well. So we've got a paper coming out on that element, but they're really receptive to it now, much more than I expected them to be, actually. So yeah, we think all of these institutes have their role to play in bringing this forwards, and we've all got to do it by communicating to each other, right? That's my view. Okay.
Great, thank you very much.
Thank you.
I think we can continue discussion during lunch or